Good morning, ladies and gentlemen, and welcome to this Alianza Cuatro Universidades. I have to speak a little bit of Spanish because we have an alliance with Spanish universities. Now, this is a partnership with 4 universities in Spain, and they are involved with the leading universities in non-European countries, and we are one of the leading universities involved in research and teaching. So we are going to have an interesting program where we will have presentations from members from the 4 universities in Spain, mainly from Barcelona and Madrid, and the University of Pretoria. And they will cover the 4 themes that you are already aware of. Strengthening public health, research on communicable, non-communicable diseases. So I think you are aware of all the 4 themes. So each of the 4 themes will have a representative from the University of Pretoria and the 4 universities from Spain. I would like to first welcome our university executives, starting with our Dean of Faculty, Professor Tian Dijager, our Deputy Dean for Research and Postgraduate Studies, who actually has been instrumental in putting together this alliance and this function, Professor Tibani Mashamba-Thompson. We also have our Head of School of Health System and Public Health. I would like to also welcome everyone, the students who are here, the heads of departments, all the presenters who will be here, our visitors. I'm excited that this is actually a visiting kind of alliance. You know, coming from COVID, we are used to things being online. Things moved to online, and many things stayed online. And, you know, when I walk around, people want to be with other people. And this is one of the instances where people will be with other people in different countries. And you will have the cross-cultural exchanges, the exchange of research, the teaching, the learning, and other things as well. So it's quite exciting. On this note, we were supposed to start with our Deputy Vice-Chancellor, for research, innovation, but he couldn't make it. But instead, we have our Dean of Faculty, who will do our welcome. So I will, on this note, ask Professor Dijager to come and give a note of welcome. Thank you.
The Ambassador of Spain in South Africa, His Excellency Rubedo, and the Spanish delegation, including the Vice-Rectors of the A4 universities, Mr. Dan de Tooy, Deputy DG at Department of Science and Innovation, and his colleagues, representatives from other South African universities. I know there's specifically from University of Witwatersrand delegates present, deputy deans, heads of schools, heads of departments, staff of the University of Pretoria, and we should not forget our online delegates. Ladies and gentlemen, all protocol observed. Good morning, esteemed guests and distinguished guests and partners in academia. It's a great honor and privilege to welcome you to the first Spanish South African University Symposium, focusing on the theme Global Health at a Crossroad. On behalf of the University of Pretoria and the Faculty of Health Sciences, I would like to express my gratitude to our Spanish counterparts for their collaboration in making this symposium possible. The global health landscape is undoubtedly at a crucial and critical junction. The challenges we face are complex, far-reaching, and intertwined, requiring not only local solutions, but also a global partnership and multidisciplinary approaches. The issues we will explore today underscore the necessity for collaborative, innovative strategies to address the health concerns and transcend borders that impact populations worldwide. Our symposium is uniquely positioned to examine global health from multiple perspectives, focusing on 4 critical pillars. First of all, the One Health approach. A recognition that the health of people, animals, and the environment is interconnected. In a world where zoonotic diseases and environmental degradation threaten public health, a coordinated cross-sectional strategy is crucial in addressing the shared risks. Secondly, preventive healthcare, as we shift from a reactive to a proactive approach. The role of prevention becomes paramount in reducing the burden of healthcare systems. Investing in prevention is not only cost-effective, but a vital and promotive in healthcare, more resilient populations that we should build. Research on communicable and non-communicable diseases. Whether it is enduring fight against infectious diseases or the growing burden of non-communicable diseases like cancer, diabetes, and cardiovascular conditions, research remains the backbone of innovation in healthcare. Both areas demand cutting-edge solutions from scientific rigor and practical application. Health system strengthening, I think we in South Africa know, is of critical importance. Our health systems must be robust, equitable, and adaptive to withstand future global risks. Strengthening these systems require not only funding and infrastructure, but also governance, workforce development, and community engagement. As we begin our discussions, I encourage each of you to engage openly, share your insight, and challenge our conventional way of thinking. Our institutions from South Africa and Spain have a long history of academic excellence and a shared commitment to advancing health and well-being. Together, we can pave the way for sustainable solutions to today's most pressing healthcare challenges. I thank you, and I look forward to a day of productive dialogue and fruitful collaboration. Thank you.
Thank you, Prof. Dijaka, for that speech. And yes, you are all welcome. And I understand that there's going to be a tour as well later on. So there will be a mixture of business and pleasure, and you'll get to see our facilities as well. Maybe I should also indicate that, this is the initial exposure. This is not the final kind of meeting that we have with our partners. This is the initial exposure where the researchers have been matched from Spain with our own UP researchers. And what is interesting is it's cross-field. You don't have people who are like for like. We have people meshed between neuroscience, neurosurgery, and engineering. In health sciences, we identify and create problems, and engineers fix them. So we want to pair with people who will help us fix our problems. And the head of Department of Neurosurgery, Professor Llewellyn Padiachi, paired with Fernando Fernandez from Spain, who deals with computer engineering and all that. But, you can just imagine, neuroscience, but it works because you need those engineering and computer solutions to solve neurosurgery, the brain, whatever problems, tumors and things like that. So you will wonder why Professor Llewellyn Padiachi is speaking. Although Fernando has been hosted by Sean Patrick from the School of Health System and Public Health, he's also hosted by Professor Llewellyn Padiachi on neuroscience. So we'll ask the head of Department of Neurosurgery, Professor Llewellyn Padiachi, to come and give his talk.
So thank you very much, Emmanuel, and thank you to our Spanish delegation, the ambassador, and the complete delegation, our Dean, Prof. Diacher, our Deputy Dean, Prof. Mashamba Thompson. Thank you so much, and all the distinguished heads of departments and academics. It's a real privilege to present some of our work here, and I wanted to make that point that Emmanuel's made now. So we've been really fortunate in that we're positioned, at a point where I believe that the unraveling the secrets of the brain in whatever capacity we're able to do, whether it's imaging, translational neuroscience, or laboratory-based stuff, or early detection, really we were positioned at a point, fortuitously, I think in many ways, where this is perhaps the kind of strongest research interest globally. So you're looking at projects like the Blue Brain Project, which a South African actually heads up, or used to head up in Switzerland. And all of these come down to the fundamental philosophy of brain connectomics. So the drive to develop the world's first virtual brain, I think we're quite a bit away from that. But recently, a publication from a previous Nobel Prize winner showed that we can actually describe the pathways in a fly brain. So just to put that in perspective, I think we're quite a way away from where we want to be, but I think the point that we need to move with that now, I think is really important. It's been quite nicely described by a leading academic that unraveling the secrets of the brain is like going from a hand-drawn map to hand-drawn maps to Google Earth. And if we look at the level of, or the quality of imaging, how we can image those pathways, not just of the brain, but through the eye as well. And that's something we've spent a lot of our time, and I'll show some of that now. And again, we've been privileged to spend some time with the computer science department from Madrid, both Fernando and Anna. And artificial intelligence is something one just can't ignore. One, in fact, ignores a completely wrong word to use. We need to embrace it in as many components as we can. And mathematical modeling is something we've also been privileged in a small way to be part of. So developing artificial limbs, spinal cord injuries, and in our context, which I'll show some of now, non-invasive ICP assessment. So this is our neuroscience group, which we really are privileged to have grown in capacity and volumes. We're comprised of MSc students, potentially a PhD registering student fairly soon, and we've divided it into a very sensible way. So 3 pillars really: an early detection and epidemiology group, which I'll show the relevance of now, a surgical adjunctive and neurorehabilitation group, which really pivots on the work that we do as clinicians, and then something that we don't have a great skill, or at least I don't have, and we've really garnered with the physiology department, immunology, anatomy, and pharmacology, where people have the skill set to allow translational neurosciences, so laboratory-based work, where we can eventually get ourselves up to the point where molecular profiling of tumors really helps us to individualize treatment. So I think we always need to start off with acknowledgement. So on the left there is the Red Cross Children's Hospital in Cape Town, where I spend the greater part of my career. I'm primarily a pediatric neurosurgeon, and now probably a 60-40 split between adult and pediatric brain tumors. Oxford's Radcliffe Infirmary, where I spent 2 years studying imaging kind of methods for the brain, and then currently Steve Biko Hospital. And really, everything we do is aimed at improving the care of some of the kids that we treat. So I think some of the best discussions that we have are socially over dinner and some wine, and Fernando has given me permission to use this. So we had a beautiful discussion, I think, and planned some things, both Anna and Fernanda, my wife and I. So I think that's the benefit of these physical meetings, like Emmanuel pointed out. So this is how our center is laid out, and I'm going to talk about the context really. So in our setting, the vast majority of children that we treat always present later than they should have. So you'll see the CT scan at the bottom shows a large, what turned out to be a cyst, not a tumor, hydatid cyst. And we published 2 papers on this, the largest intact removal, and it's great to do that. But I would argue that in our context, we should be diagnosing these conditions earlier. That's our primary goal. So we focused our research, at least one of the avenues, on identifying ways non-invasively of picking up raised intracranial pressure earlier. So we can pick up these children a lot easier, and not just children, I say children, but adults as well. And that evolved into a study where we identified the described techniques, we validated them, and then we refined them, which allowed us to build really productive research collaborations with engineers from Norway, and we're hoping to extend that now to Spain as well. So our collaborative focus, tumors, adjunctive tools, diagnostic advances, molecular profiling. Traumatic brain injury is something in South Africa we see a lot of, so our neurocritical care is a big deal as well. And then neurorehabilitation has emerged as a fundamental part of this. It's pointless diagnosing early, treating well, but not finishing that off with a coordinated rehabilitation approach. And that combines really well with things like neuromonitoring, where we monitor the pathways, we image the brain, and these sorts of things come with funding demands and research collaborations, and really tying very well into the focus of this group. So we've spent a lot of time developing ultrasound techniques because it's non-invasive, it's portable, it allows us to scan the eye, the ear, really access the cranium and the brain through those little portals. And I'll show some of what we've done, but really the kind of potential areas for research. And this is the why developing a non-invasive, reliable tool like a thermometer really for measuring temperature to measure the pressure in the brain is such a lucrative thing. So the eye as a window to the brain is really such a kind of biblical and philosophical concept, but we've used it in the context of diagnosing raised ICP, and I'll show quickly. So we've developed over the last 2 years now really a state-of-the-art neuro-ophthalmology laboratory, and we're able to image the eye all the way from the pupil all the way back to the cortex of the brain, which is really unique in terms of a global context in terms of the equipment we managed to acquire. So we do fundoscopy, we scan the eye. This is both pre and post-operative for early diagnosis, but also to monitor outcome. We measure intraocular pressure, so the pressure in the globe itself. We used tonometry for that. The pupil, like I've said, we do this with infrared automated pupillometry. Perimetry, we're able to pick up sort of scotomas or lesions in the eye that really allow us to identify lesions in the brain a lot better. And then something quite sophisticated called optical coherence tomography. And through some equipment funding, we've managed to purchase this portable optical coherence tomography, which is only one of a few in the world at the moment. Allows us to scan at the bedside. And putting all of this data together with our ultrasound work, really allows us to build some of the most comprehensive point-of-care diagnostic equipment, or at least parameters that have been described so far. So that's really the context of our diagnostic work. And just to put that in context, so Google have picked up on this sort of thing, and they've developed an eye scanner. And Google's new AI algorithm predicts heart disease by looking into your eyes. So we're kind of on a tangential track trying to look at algorithms for predicting raised ICP and vis-a-vis tumors and other abnormalities in the brain. So just to show that this is something that is quite modal. It's not just the eye, but you can, so this is some of the work that we've done, just quickly, some of the publications that we've already managed to get, or some of the work we've managed to get published, and we've translated the static imaging into a dynamic imaging. The details we can explain, but the auditory canal as well, using the ear as a measure of raised ICP, something that Apple have picked up on. So they developed earbuds for measuring intracranial pressure. So again, these are things that I think in the current context with artificial intelligence is really something that will develop, and I think we're really privileged to be part of that. So the beauty and irony is, I want to point this out, we started off trying to diagnose raised ICP in children because that was the context of our work. Turns out before they can send any astronauts to, well, the moon and even to Mars, they need to be able to diagnose raised ICP non-invasively within a spaceship. So all of these will translate from a very primary rural diagnostic development tool, potentially, I'm not saying guaranteed, but potentially, and we've built research collaborations with Baylor College as well, into something that's used potentially, to diagnose raised ICP for astronauts. Our surgical adjuncts, which is the second pillar of our center, the modern neurosurgery theater, like Fernando will attest to, is quite an intimidating place, especially for an engineer. We've got neuronavigation systems, minimally invasive intraoperative guidance, monitoring, all those sorts of things. So punching all that data into an algorithm that is machine-driven or artificial intelligence really is positioned quite well for the kind of interactions that we need. So this is a GPS system where we use to localize specific lesions in the brain, because in the brain, 1 millimeter means you'll be able to move your right hand or not, you'll be able to speak or not. So these things need to be precise. And robotic-assisted, artificial intelligence, whatever one wants to call, is really something that's positioned well in neurosurgery. Just to show some of the work, I tried to remove, some of those pictures because I know not everybody wants to see those sorts of things. But this is what the setup looks like, and integrating all of this data really is the value of what we're trying to do. And how that positions well here is we run this course pretty much all over the world, but specifically in Barcelona. This year was our 4th rendition of the Masters of Brain Ultrasound in Neurosurgery. We run it with the Children's Hospital in Barcelona as a yearly thing, and every year we've managed to fill the course up completely, and we've built quite strong collaborations already with the team in Barcelona. So really, that is something we can hopefully use to pivot off as well. Rehabilitation, which is I'm going to use to close now, and something I spoke extensively, or we spoke extensively with Fernando and Anna about. So this is a kid, and I think the best way to do this is to show an example. So a 4-year-old boy who came in, just showing you what the MRI scan looks like, with a lesion in the spinal cord, and he was a spastic quadriparetic, so he couldn't move his upper limbs and he couldn't move his lower limbs as well. In fact, he was already running into breathing pattern abnormalities. So just to show the context, so we removed this. I didn't show the surgery. I didn't think it was relevant to show, but we removed that in total. And again, I make the point that we should have diagnosed that earlier. A kid shouldn't have to present, quadriplegic before we need to remove a lesion. So neuromodulation, neurorehabilitation, and we're really privileged to have a state-of-the-art rehabilitation facility just down the road, which Fernando visited. And I've got permission from the mum to show this. So this kid came in spastic quadriparetic, could not move hands or legs. At 6 weeks, you'll see, sorry, it's playing the other way around. But at 6 weeks, you'll see what he was like, able to sort of move with difficulty. And if you're a 2-year-old kid and you find that you're able to walk again, the first thing you want to do is look into a mirror and prove that you can dance, apparently. So that's what he's done. And just to show the context of the work that we do, a lot of this is great to show, early diagnostics, laboratory-based stuff, but actually how that translates into improved patient care is really important. That's the goal of what we're trying to do. So translational neuroscience, I've added that as well. Like I said, we're fortunate to have included in our center really kind of prominent laboratory-based scientists, and really what I want to close off with is saying that it's important that we realize whatever we do is insignificant, but the fact that we must do it and do it as well as we can probably is the most important thing that we can do. So thank you very much for the time and the opportunity, and we look forward to building collaborations as we go along.
Thank you very much, Prof. Padiachi. Very interesting work. I mean, the developments. I'm going to watch that space. I'm asking myself, when I speak to Prof. Padiachi, should I look him in the eye? Because I'm now, from what he said, I'm starting to think, is he going to tell me something about my heart or my brain? And that is how much science has advanced, and that is the reason he's partnering with computer and engineering, so that they can actually see your soul, if you like, and then tell you how you can fix it. Thank you very much, Prof. Padiachi. We are now moving on to the main themes that are the main focus of really this alliance. And we are going to start with the first one on One Health approach. I must say, when I saw the 2 flags of South Africa and Spain, I couldn't help thinking about the 2010 World Cup. South Africa hosted the rest of the world, and Spain won the World Cup. And here we are, having these partnerships together. I think that is lovely. Shall we now welcome Dr. Rafael Molina? I know of a certain famous Rafael from Spain who plays tennis, on the theme One Health approach. Dr. Rafael Molina He will be partnering with Professor Nanette Gwana from the University of Pretoria.
Good morning. I'm not a singer, for sure. I'm not a football player. Thank you very much for the invitation. I'm a veterinarian, a practical veterinarian working in a wildlife facility, so I will share my experience as a veterinarian. For me, it's also a good opportunity to share my time with 3 more veterinarians, because veterinarian has to say a lot of things about the One Health approach. And what is One Health? Look at the definition. That's the definition of the World Health Organization. And I think we have to consider 2 parts in this definition. The theoretical part, the important probably for us as veterinarians, is that we have to understand the health as an interconnection between health of animals, human health, plant health, for sure ecosystem health. That's the important part. And the second part of the definition is a more practical, how to do that. That means that we have to work all together in an integrated way, trying to obtain the better outcomes in health indicators for human, animals, plants, and ecosystems, if possible. And I'm very proud to be a veterinarian in this, when I talk about this topic, because this concept is a concept that the wildlife veterinarians or veterinarians in general know for a long time, because we are dealing with zoonosis, and for us it's clear that diseases are shared between humans and animals. So this definition of One Health was done or was created in this conference 20 years ago in the United States. And the conference was hosted by the Wildlife Conservation Society, because I think wildlife veterinarians are very sensitive to this change in the approach of health. Do you think it is easy to apply this approach to the health? I think it's very difficult. We have to consider a lot of factors. Look at those pictures. Social factors are very important. Education is a social factor for sure. Economics is the critical factor, and for sure cultural factors. You can see in those markets animals without any welfare or protocol welfare, maintaining into cages, close different spaces, a pangolin with a snake. I don't know if you know what is the snake is clear, the pangolin is the other creature. And if there is no welfare protocol, there is more stress means immunosuppression. Immunosuppression means spread of diseases or of infectious diseases. You can see in other part of the slide that raw meat is put together with cooked meat without any cold change, without probably any veterinary inspection or hygienic control. Look at the other girl sleeping or resting close to the poultry. Or those guys sacrificing the chicken of course, it's not in a slaughterhouse. So there is no prevention measure for control of the quality of the food. And this is also more factors that affect the complexity of this approach. That's the world is changing very fast. The population is growing. The globalization is a reality. The planet is warming. We need more food. We need to transform the landscape. We need to make more crops, to breed more livestock. This changes ecological factors like the distribution of vectors. Vectors are very important in the transmission of a lot of diseases, a lot of zoonosis. If the environment changes, there is a more contact between domestic animals and wild animals. It means that there is a risk of transmission of microorganisms between them, but also more contact between wild animals and humans. That's the perfect storm. In this scenario, what happens? It could happen this scary situation, the jump of the species barrier. That means that one particular microorganism could pass from one cow to a human, or from one wild duck to one chicken, from the chicken to the pig for the human. That's the real situation. So the risk of emergence of new zoonosis is very high. In fact, it happens. And not only zoonosis, also emerging infectious diseases that affect wild animals and domestic animals. And what can we do? What's the practical way to manage this situation? The only way you can do that is working all together. I think for a long time, I feel a little bit small here because we are all scientists and I'm a practical veterinarian. So I'm in the primary level of the healthcare of animals, and probably is difficult for me to explain these basic concepts, but I think that for a long time, human doctors or practical veterinary practitioners are focused in the health of the single patient. That's our job. That's our way of life. But we have to take a more wide vision of diseases. We have to consider the diseases and a population, for the impact of diseases in population, and to have a more deep knowledge of the ecology of diseases. It's a new field. And probably I always say to my students that we have, the owners of the animals and the zookeepers, say you have to understand the disease from the point of view of the virus. For the virus, your respiratory epithelial cells are the same if you are a human, in some cases, or a chicken, or I don't know, a pig. So you have to understand how it works if you want to control the virus or other microorganisms. It looks very simplistic, but it's a way that works for me to try to explain how diseases works between animals. And what we expect to, what are our results, what are our outcomes? In practice, applying this approach, this One Health approach, we have to improve at the end safety and food security. Remember the first slides. Also a reduction of the use of misuse of antibiotics. Dr. Darwich will explain this topic later. For sure, a protection of the global health security. It will be very important to prevent outbreaks of zoonosis. That's a critical point. I will show you one example, well known for all of you. And at the end, protect biodiversity and conservation of species. This is very important. Look at the planet Earth as a huge system. Remember the concept of Gaia of Dr. Lovelock in the 80s. I think this concept is now it's very useful to understand what happens currently. So it's important to protect the biodiversity because the balance is very thin. Okay. That's why zoonosis, I know you are familiar with this concept. Zoonosis are diseases that naturally are transmitted from humans to, sorry, I'm veterinarian, from animals to humans, sorry. That's the bias I have always. And look at that 65% of emerging infectious disease in humans are zoonotic origin. And 60% of infectious disease are spread from animals. So we have to take care of what happens with animals and humans. And remember the last worst crisis, health crisis in the world, the COVID pandemics. It was, I think, it was the most strong evidence that zoonosis are really important. But I'm a veterinarian, we have to consider that the flow of infectious agents are not only from animals or animals to humans, but also from humans to animals. That's a huge problem also. During the COVID crisis, zoo animals were infected by the keepers, pets, dogs, and cats, at least in Europe. There was a huge problem with mink farms. Mink are used for food production, and mortality in general are very sensitive to this virus, and the disease was devastating from the animal. It was a very bad picture, very severe lung disease, and in farms affected and infected by the coronavirus was necessary to kill millions and millions of minks in Europe. Try to imagine the global economical impact in those countries and for those people. And for sure, it's very important to consider this flow in the other direction from humans to animals when you are working with endangered species. The mountain gorilla, for example, is very close, or chimpanzees are very close to us, 90%, more than 90%. We are chimpanzees more than 90%, probably, I'm not sure. The UICN, that is an organization dealing with the conservation of nature, published some bans proposing mitigation strategies to limit the contact between humans and these species during this period of crisis, because the risk for the population of the transmission of this disease is very high. And you know that now we are in South Africa, the wildlife tourism is very important. And try to imagine in Uganda or Rwanda when people visit these groups of very sensitive species to this infection. Okay, that's the general introduction. Now I will share strictly my experience as a practical veterinarian. So I'm working in one rehabilitation center, and you have to understand what is a wildlife rehabilitation center, and I will try to explain why are important wildlife rehabilitation centers. For sure, we all know because we are keeping wild animals, injured animals or ill animals, and we try to release those animals to the wild. Excellent, you know, it's the traditional work. We are also contributing to captive breeding for translocation and reintroduction of species. Well, no, for sure, we do a lot of research if we have funding, because we have the opportunity to work very close with animals. One of the most important parts is education of professionals and education of children visiting the center. I think education is the key of all the One Health approach. We are doing a lot of forensic medicine, investigating wildlife crimes and animal abuse, a lot of work, and for sure we do disease surveillance. And why? Not only emerging infectious disease of wild animals, but also zoonosis. And why is important? I try to invite you to collaborate with wildlife rehabilitation centers if you are working in health programs, because it's a good option. Look at the Spanish map. Spain is almost half of the surface of South Africa, and we have 65 wildlife centers. You can see that each dot is one rehabilitation center. They are distributed in all the country. We receive a lot of animals, in our particular case, more than 15,000 per year. Small animals, not elephants, not lions, but a lot of animals. And a huge diversity of species. That is very important from the epidemiological point of view. We are open all year round. This is very important because you can bring the animal every day. And we collect, it's an hospital, we collect data of the animals. That is very important for epidemiological studies. That's the summary of the process of rehabilitation. It's only 2 comments. One comment, there are 2 critical points. From the point of view of our occupation of our staff, there is a risk of contagious, of infectious or zoonotic diseases during all the process of rehabilitation of the animal, handling, cleaning, feeding. For sure, I'm doing a lot of necropsies during the necropsies. And the second critical point is when you release the animal, you have to check the health condition of the animal and to test infectious, some diseases is very expensive, but in most of the cases it's not possible. So we have a huge responsibility releasing animals that could be carriers, I don't know, of salmonella or other agents. And it's not always easy to follow our hygienic or safety protocols. In some parts of the year, I think it's the same in other areas, we have a lot of work, more than 200 cases per day. If you have this huge charge of work, it's impossible to follow any protocol, impossible to have a quarantine, impossible to wear the PPA because you have to clean your washes 100 times in one morning. You know, it's difficult to apply. You have to take samples. Try to take one sample in these rotten corpses or one duck. You could identify the duck. It's almost impossible. Just maggots, maggots, and maggots. It's not possible to take samples of this kind of corpses you receive to investigate an outbreak of disease in summer. So we know the theory, but to apply that in our daily practice is very difficult. And I will show you two very short examples of surveillance of diseases that we do every day. One, I'm proud of our task, and I will invite you to collaborate with Wildlife Rehabilitation Center in your country. We are contributing to all these surveillance plans. All of them are official plans depending on the government, so we have to do that. And we are also participating in the investigation of outbreaks of many diseases. You know that avian flu is a very important disease, at least for the poultry sector. It's the economical implications, if we are positive cases, are very, very, very strong for the countries. And we have to send samples to the lab in a coordinated plan in all Spain, sending samples and doing passive and active surveillance. And during those years, we have to adapt to the new situation. One of the problems, you know that the surveillance plans are very fixed. You have to monitor some areas, risk areas, certain group of species, especially aquatic animals, birds in this case. But when you receive an animal in the center, a lot of the cases, like in human medicine, the clinical presentations is completely unspecific. And the economical resources are limited, so you have to choose, yes, you're not. According to your clinical experience, probably you miss a lot of cases. In this moment, we have a problem if it's the case, if positive. Look at this case. The first case was detected in Catalonia. It's the part of Spain we are from. In one of the most recent outbreaks of avian flu was diagnosed in one wildlife rehabilitation center. And the veterinarian, Maria, has his clinical intuitions. He said probably it's avian flu. In fact, it was positive, and the consequences for the poultry farms around the wildlife rehabilitation center was very important. They have to sacrifice a lot of ducks and geese and chicken and immobilized animals. It was very grave. Since this outbreak, the situation and the epidemiology of the disease has changed a lot. Every year we had cases of avian flu. Look at the numbers in our center. I saw my first case after 30 years of working with birds in 2017, and last year we had 34 cases in winter. That's a normal part of the year. The normal season we receive the migration of birds from the east of Eurasia. But we have also a lot of cases, outbreaks in summer. It's completely different. It was devastating in the wildlife colonies of seabirds. So we have to invest a lot in surveillance of this disease because the situation of the disease has changed. And my last example, and I will finish, is with these poor guys. I think bats are a damned animal. It's important to know that they are probably the most important reservoir of infectious disease in the animal kingdom. And importantly, they carry rabies, not the classical virus of rabies. The Lassa virus is the family of rabies virus, and they carry 17 or 19 different types of Lassa virus. In Europe, we have our Lassa virus. My colleague, Elena, one of the other veterinarians in the center, was very sensitive to rabies. He said, we have to look for rabies in our bats. And we start to send samples to the Instituto de Salud Carlos III, the central laboratory, the most important laboratory in infectious disease in Spain, because they have a very good virologist, Dr. Juan Emilio Echevarria. Usually love is an authority in bats diseases, and we start to send samples, and finally we obtain 3 positive samples in bats. And moreover, they describe a new variety of Lassa virus from animals from rehabilitation centers. But what happens during this process? They have one case or one bite of one bat to one human. And it was after this moment we decide to increase the surveillance programs, and all the partners, the responsible of the wildlife rehabilitation centers, that is the agricultural or environmental department, because it changed depending on the political situation. And most important, the responsible of the human health system and ranger sit at the table, they decide after the first case of biting of a positive bat to implement a specific protocol for surveillance of this virus infection in bats. And it was the result of our perseverance, trying to look for rabies, because we will find, and finally we have this protocol. We are very proud. That's the way we take samples of bats. We have insectivorous bats, very small bats, comparing to your fruit bats. It's different, but that's our species. We have to take simply a saliva swab sent to the lab, and they do molecular techniques for the diagnosis. That at the end, this is the protocol. And you can see that if there is a bat bite, we have to send immediately the sample to the central laboratory in Madrid, and we have to contact immediately with the head of the health human department in Catalonia, and with the head of the environmental department. And the person that has been bitten, they start with a prophylactic treatment of the disease of rabies with vaccination, blah, blah. And the most important thing is that doctors in the primary care knows now that there is this specific protocol working, and that bats could transmit this Lassa virus infection. So that's my offer. You have a wildlife rehabilitation center in your countries. Know that zoonoses are very important, that we receive a lot of animals, and that we are open to share our samples, because it's good for us, for protection of our staff, but more important for protection of the general population, because we are at risk of all those diseases. Thank you very much. I could sing, but I prefer not.
Thank you, Dr. Rafael Molina. I would like to call upon Professor Llewellyn Padiachi to come to the fore, and there's a small token from Prof. Mashamba Thompson from the faculty and the university. Thank you very much. I mean, what Dr. Molina has highlighted is very important, that we are all interconnected. How we treat animals, how we treat the environment has a bearing on our very own health. I couldn't help thinking about the last 2 major outbreaks in the world. COVID-19, the previous one from a certain country, named after a country, the Spanish flu. And if you think about it, there are also suspicions that they emanate from animals. And what was being highlighted here is that the One Health approach is now, is present, and that is how we must move forward. Although we have different faculty as vet science, we have faculty of health science, we deal with people, they deal with animals, we are all interconnected. What one does has an impact on the other, and that we should always bear in mind. I will ask the speaker from vet science, Professor Nenene Cegwana, to come forth and give his presentation.
Ladies and gentlemen, I don't know if you can hear me. Good morning. Raphael, I think you have done a good job, so I should be very brief, 5 minutes. So I think we said yesterday with Raphael and said, okay, let's try to see how we combine the 2 presentations. So I'm not going to be long. I'm just going to give you the South African context. Ladies and gentlemen, good morning. My name is Nenene, as indicated. So I'm from the veterinary faculty, the most beautiful faculty where you have animals walking around. So you should come visit. But so Raphael has also kind of indicated to you that the issue of disease management is very complex. So trying to figure out mitigation strategies requires a transdisciplinary approach. And there are many examples that Raphael has given in terms of how we can go about doing this. So I want to give you some of the examples, I think, some of the things that I want you to think about as a take home. So there's what we call a societal context in which we talk about disease management. And it's easier for us as researchers to think about strategies and policies that addresses disease without thinking about societal context. And then I'll show you some of the examples of what I mean by societal context. We need to accept that, especially in low-middle income countries, we are struggling with issues of health systems that are broken. Whether you're talking about animal health, you're talking about environmental health, or you're talking about human health, our systems are broken. So if you're going to develop policies or you're going to deal with disease, whether you're talking about rabies, hospital-acquired infections, the societal context is important. So as researchers, we need to think about the spaces we live, the spaces we work, the people we interact with, how those interactions and spaces influence the work that we actually do. So this is the spaces in which I work. So you can clearly think that although here the focus is to treat a pig as an example, you are called to deal with a pig, but you are dealing with a bigger problem, environmental issues. If you're going to think about issues of AMR, food safety issues, you're dealing with a person that is working close with the pig. You got to think about if this person has an infection, he has to go to the hospital. Which hospital is this person going to go to? What is the resources that is available? So societal context is important when you are managing or dealing with disease. So that's the One Health concept or approach that we are actually talking about. So where we live in South Africa, where we work as veterinarians, we are dealing with a lot of disease burdens. We're talking about animal disease as well as human health issues. And when we try to address sometimes animal health issues, we end up being psychologists. We have to listen to farmers. We have to listen to their problems. We have to be politicians. You have to try to figure out how to help them. So as veterinarians, we have this wide scope of dealing with issues. So I want us to think about when we live here, when we're talking about One Health mitigation strategies, what is the context in which you are proposing or suggesting mitigation strategies, and whether those ideas and policies that you are trying to implement will actually be relevant to where you're actually working. So this is, I'm going to use the context in the veterinary faculty. So we are privileged to be full of antibodies as veterinarians for different diseases. So we had an outbreak in 2008 at the faculty, actually around Gauteng, and then we had one of the cases that was presented to the faculty. And one of the students actually was in my class, ended up with a Rift Valley fever infection. He was actually hospitalized for quite some time. So that's the context in which we as veterinarians work. So when we see disease, we don't run away, we run to diseases. So most of us are walking around with, antibodies. So we need to be thinking, how are we going to work in terms of our farmers, our students, if we're going to try to mitigate these diseases. Another example is the study that is done by Dikeledi looking at before patient contact, especially looking at escape pathogens. These are finally students that are coming into the ICU. They have not touched an animal, but most of these students that are coming into the hospital, into the ICU from home with pathogens that we actually don't want to see, most likely to be of human origin. So Raphael was talking about the transmission goes both ways. So what happens at home actually impacts your pets as well. And that's something that we actually don't think about. The other part that we've been working on is the issue of justice. How do we look at justice in a broad understanding of disease mitigations? And an example of that is when you're talking about antimicrobial resistance, and especially for farmers, when you're talking about reducing antibiotic use, access to antibiotics, its impact on production system. So we need to be thinking who's affected, how are they affected, their livelihoods. So the issue of what they call distributive justice is something that is a concept that is new to public health, but it's very common in law. And some of the concepts that you need to be bringing when we're talking about mitigation for diseases. The other one is issues around procedural justice. We had a very interesting case this year where the government decided to withdraw access to over-the-counter rabies vaccination for lay people, but there was an issue of procedural justice because those people had access to those medication for a very long time. So those are the some of the things that we need to be thinking about from a public health point of view. So in my last slide, I think it is my last slide, there needs to be a meaningful reflection when we're talking about global health issues, that the South or the North are not the same, and the context is different. So we need to be thinking about how do we prioritize mitigation strategies that are relevant and impactful to our current situation. So Raphael is dealing with something that is similar to what we are dealing with, but you might find that the mitigation and the strategies that we want to implement are completely different. So how do we create synergy and collaboration and understanding? So I did stick to my 6 minutes, Raphael. So thank you very much.
Thank you very much, Prof. Kekwana. You have widened the net. What happens at home has an effect as well. So the One Health approach is actually much broader than I originally thought. So it really involves a whole lot of aspects that need to be taken into consideration. We are now moving on to the second theme, which is preventative health. You know, inoculations, taking care of your nutrition, exercise, how also that impacts mental health. And by the way, today is World Mental Health Day. Just thought I should remind you, especially when it's so relevant for this particular theme in preventative health, because it does deal with it as well, because all these other aspects that it addresses have a bearing on it. Now, the first speaker on this theme will be Professor Laila Dawish.
Good morning, everybody. I'm going to talk about the importance of antimicrobial resistance and the preventive strategies that we can implement it under the One Health concept. Before starting, I would like to define what antimicrobial resistance is. This is the capability of microorganisms like bacteria to resist the effect of an antibiotics. It's important to point out that the antibiotic resistance can be transmitted from animals to humans in both senses. And that's why it's one of the major health threats in the world. However, most of the people are not aware of this, but it's in fact, they are a silent and a rapidly escalating pandemics. In fact, according to the international health organizations, it is estimated that 10 million deaths per year will be caused directly for resistant bacterial infections. And most of these deaths will be concentrated in Africa and Asia. Basically, why in these regions? But because they are the regions that we have the highest levels of population growth. This year, we reached the 8.2 billion people in the planet, human beings. And only with India and China, it's almost 3 billion people. So it's a great concern because there are a lot of people, and also all these people need to eat. That's why we have to, the animal production has suffered an extremely intensification. So you can see in the map that in red, basically in regions like China, India, Southeast Asia, it's extremely important, the production of pigs and poultry. So all these situations will have an impact. Why? Because if you have a lot of numbers of animals, we are talking about 100,000 animals in the same enclosure. That means that the transmission of infectious diseases between animals is very high. So you have to use a lot of antibiotics to prevent the transmission and to save the health of these animals. That's why if you are using a lot of antibiotics, there are a lot more risk for the emergence of multi-drug resistance bacteria. And that's the main problem. And where are the overuse of antibiotics? You can see here that is in China, basically, and in Asia and South America, in Brazil, basically. Also, there is a big impact of the use of antibiotics. And there are, the legislation of the use of the consumption of antibiotics is lower than in Europe and other countries. Why in China they are using a lot of antibiotics in animal production? You can see in the pictures, they are building mega farms with thousands of pigs contained in a 26-story skyscrapers, like in the picture. And also pigs, but also dairy cows. So this is an insane way to produce animals, of course. And there is no regulation of the use of antibiotics. That is a big concern. But the antibiotics are not only used in livestock, they are also used in a huge amount of tons in aquaculture for the fishes. So also you have here thousands of fishes in small areas. So the transmission of virus, bacteria, parasites is very huge. So you have to use a lot of antimicrobials to avoid the transmission. And not only in animals, but also in plants. in plants, and there are some countries, Europe and West Africa, have more regulations in the use of antibiotics in crops and in vegetables, but in other countries like Asia and America, they are using a lot of antibiotics, even more than 5 or more antibiotics for the crops. You can see in Vietnam, they are using a lot of antibiotics for the fields of rice. So all this use of antibiotics are creating more resistance in bacteria, and then they are contaminating and polluting the environmental health. In order to, in Europe, in order to promote the prudent use of antibiotics, they are elaborating by the European Medicine Agency the categorization of the antibiotics for animal use. And these antibiotics are categorized according to the risk to the public health. So in category A, in category A, we are including all those antibiotics that are the last resort for human medicine. That is carbapenems, vancomycin, etc. And they are not allowed to use in food-producing animals. You only can exceptional use in pets, and under the proof that you have an antimicrobial susceptibility testing, proving that all the other drugs that are in below categories are resistant, okay, are not useful. And in category B, we have also other, you can use it only in exceptional circumstances when you cannot use category C or D. And and for use of animals, it's more adequate to use category D, prudence or caution categories. So this is the regulation. In parallel, the World Health Organization also created the Aware Antibiotic Book that is regulating or classifying the antibiotics for human medicine in 3 categories. The access antibiotics, that are those that you can normally use because they are a low resistance potential, and the watch antibiotics that are reserved to treat patients with the more severe clinical signs. And then we have the reserve antibiotics that are used in cases that with infections with multi-drug resistance infections. Okay, so let's see in the last 10 years, if all these strategies have had an impact in the consumption of antibiotics in Europe. And you can see it's the first time that in 2016 that the use of antibiotics in animals was lower than in human medicine. It is an achievement. It's enough, let's see. This is in the last decade, in 10 years, the sales of veterinary antimicrobial agents have reduced by half the use of antibiotics. And it was practically because the use of colistin, I don't know if it's a polymyxin that was very used for preventing the post-weaning diarrhea in pigs, and it was using like in the food for animals. So they were creating a lot of resistance to colistin, and you know that colistin is also a last resort antibiotic for human health. That's why with the restriction of the use of colistin in veterinary medicine, there was half of the medications in veterinary dropped quickly. However, there is still an improvement because we are using a lot of fluoroquinolones that are also category B for human medicine, for like enrofloxacin and morfloxacin, that we can improve in reducing the use. So all these mitigation strategies focus on animal health and food production and veterinary science. Let's see if they have a real impact in the environmental pollution. So I'm going to explain a little bit which are our principal findings, because we are in the infectious disease unit in the vet school. We are working on antimicrobial resistance in livestock, like pigs, and also in wildlife for more than 20 years. and we have a collaboration with the Wildlife Rehabilitation Center. So here I wanted to show you which is the situation of Catalonia and Spain of the environmental health. Basically, in all the species of wildlife that we check for antimicrobial resistance, we found it. And the principal reservoirs of these bacteria were basically the European hedgehogs and some mustelids. You can see here that most of the bacterial species that we found in these animals are those that are normally described in a nosocomial environment in the human hospitals in Spain. And most of them are containing resistant genes that conferring resistance to the last resort antibiotics, like extended spectrum beta-lactamases, ES vireals, and carbapenem resistance genes. So it's a big concern because carbapenems are not used in veterinary science. So all these contaminations are coming from the human field. Again, moreover, also raptors, hawks, and different species of owls also have the same picture. A lot of bacteria with a lot of resistant genes. We were working more deeply with the European hedgehog. So what we saw is like that 37% of the hedgehogs already have these critical genes of resistance. And this is the picture of the Klebsiellas, basically E. coli, but Klebsiellas pneumoniae that these animals show. You can see here two, three, or more different antimicrobial resistant genes contained in these animals. They are animals that have never been treated before with an antibiotic, are attended in the Wildlife Rehabilitation Center. We take the sample and we analyze it. Why these animals are concentrated this huge amount of bacteria, nosocomial bacteria from human origin? Because one of the diet of these animals are the earthworms. And it is known that these worms can accumulate and concentrate antibiotics concentrations and also antimicrobial resistant genes inside from the fields, from the soil. So that means that the soils are very polluted with these residues. And finally, we wanted to show you that we also make some environmental surveillance in water. So we analyze species that are semi-aquatic life, like invasive species like the American minks and some sliders, turtles, that are colonizing the rivers in Catalonia. And of course, all these animals that were in the rivers of the big cities like Barcelona, Tarragona, with a huge impact of urban areas, they were colonized with the same bacteria and antimicrobial resistant genes that we can find in the big hospitals. However, others, the animals that were in rural areas with a high density of pig production, we could find that the genes changed, and they have colistin-resistant genes that is produced by the pig farming, no? And I have to say that 8 years from the restriction of the use of antibiotics of the colistin, we can find these genes in the environment. So they are very stable in the waters. That it's a problem. You can decrease the use of antibiotics, but the resistant genes are still in the environment because they are transmitted by plasmids. I don't know, well, doesn't matter, but they are very stable and they can persist during years in the water, in the soils, and it's a big concern because makes more difficult to control the situation. Finally, this is the final picture that we can summarize the most relevant findings of our research. As I told you, all the overuse of antibiotics done in the human medicine and veterinary medicine has created a lot of antimicrobial resistance bacteria that finally goes to contaminating to the rivers and the soils through the sewage, the wastewaters from the urban areas, also from the manure from the farms. And finally, these wild species are acquiring all these bacteria and these resistant genes. And that's why they have a good value as good sentinels of the environmental health, because it's a good way to monitor all the situation. Well, so how can improve the situation and how can reduce the impact of all this AMR in the environment? Well, we have some ideas. Some of them are difficult to put in practices, but as you know, to create new molecules of antibiotics is not easy. But to do alternative treatments, like improve the gut health, using probiotics, using new vaccinations, like to improve the immune systems to be more effective against these infectious diseases. Again, it's more critical to change the production models to reduce the intensification and to produce more sustainable models of animal production to preserve or the animal welfare. If you have happy animals, you will have healthy animals, so you have to use less the antibiotics on these animals. You have to treat less. And of course, we have to develop new diagnostic tools or improve the diagnostic tools that we have take off point of care devices, because we need to know which is the susceptibility of a patient against which is the best antibiotic that we can use to treat the patient in hours. We cannot wait 2 or 3 days to know which is the best antibiotic to treat. So we have to improve faster devices. And finally, educational programs are really important to raise the public and the stakeholders' awareness is very important. So education programs, not only for professionals and farmers, but also for the general population and the primary schools, the kids, they have to know that they have to use the antibiotics in a prudent way. Also, you have to apply for global environmental policies altogether, and to increase and to invest in research, basically in new technologies that can to try to remove all these antibiotics and all these antimicrobial resistant genes from the hospitals, maybe to providing better filtration systems, or from the farms making treatments in the manure before to be released in the wild or in the fields. So it's very important. So I'm calling for biotechnologists and engineering to participate in creating this kind of technologies that are necessary to remove all this contamination in the environment. And this is all, and thank you very much. Hope you enjoy.
Thank you, Dr. Laila, Professor Laila Dawish. I got a bit scared, you know. The other day I was at a butchery and I was buying some meat, and the butcher proudly told me, "This comes from Brazil." Now, Professor Davies, from what you said about the use of antibiotics, which is not so well regulated, and the red dots that you showed there, I'm thinking to myself, if these are ingested with these antibiotics and we end up eating these animals, what happens to us? It got me thinking, does the antibiotic evaporate and not come into our system? And what is happening to my Brazilian meat? I'm left to think. Really serious stuff to ponder. Thank you very much for your presentation. We will move on to a rep from the University of Pretoria from Veterinary Sciences, Dr. Vashni Govender, to come and give presentation.
Good morning, a very distinguished guest. It's really an honor to be here as part of this symposium. So under this theme of preventive healthcare, this presentation is meant as a continuation of Professor Darwich. And I'm going to focus on strategies in the control of antimicrobial resistance as well. As you probably realize, as veterinarians, we love talking about antimicrobial resistance. And I hope from the previous presenters, you can acknowledge that really antimicrobial resistance is the quintessential One Health issue globally, because it's being acknowledged as the current silent pandemic that is ongoing and not necessarily getting the attention that the concern that we have really drives. So yes, from One Health, you know that we need healthy environments and healthy animals to have healthy people. And my veterinary colleagues that have presented before me have really made my job a lot easier, so I'm also going to be quite brief. So just to touch on how we're using antimicrobials in animals, so similar to our human health counterparts, we do use antimicrobials therapeutically to treat sick animals. However, more common practice is using antimicrobials in healthy animals, so either prophylactically and metaphylactically, where we anticipate disease, but also for growth promotion, and this is really to improve the utilization of feed in our livestock. And with the use of these antibiotics, we run into a number of problems. If we consider the environment, not just the contamination with resistant bacteria from livestock production systems, but also residues that are excreted that contaminate soil and water sources, which are then used for crop production and food production for people. So the vegetarians and vegans are not exempt from this problem. And then we also have the zoonotic transmission of resistant bacteria, either through direct animal contact, so those of us that share very close contact with our pets, we love them and we love having them near us, but also for farm workers that are work in very close proximity to their livestock. And then for consumers that might encounter these resistant bacteria in animal products, food products of animal origin, not just resistant bacteria, but also antibiotic residues that might be present in these food products, so meat, milk, eggs, etc. So this is the last report that was published by the Department of Health, not the latest one, however, but the latest one that included animal health data. And as you can see in South Africa, we tend to be using consuming much less antibiotics in the veterinary sector or the animal health sector compared to the human health sector. And in this report, we published some data from the South African poultry industry, which showed the colistin resistance in E. coli strains recovered from poultry in South Africa. It's important to note here, colistin is one of the last resort drugs in human medicine, particularly in oncology. And this drug was quite used with some freedom in animal production in South Africa. And this caused the South African Veterinary Council to actually impose very severe restrictions on the use of colistin in animals due to the development and recovery of superbugs from the sector. So this report showed that colistin resistance in these isolates declined quite significantly following the restriction of use in the veterinary sector in South Africa. And we've also seen a decline in resistance of oxytetracycline, trimethoprim sulfur, neomycin, and quinolones. Also that trend since 2007. So based on that, it makes sense then that one of our preventive healthcare strategies for antimicrobial resistance control would be focused on reducing antibiotic use at the animal level. So here I would like you to consider the concept of primary animal health care, similar to that in humans, but in this context, not just relating to the early detection and treatment of diseases before they become complicated, but also preventing those diseases from happening. So if we consider the use of antibiotics for growth promotion, how do we actually reduce those? So one of the main strategies that we can employ is the use of breeding practices and genetic selection for animals that can actually utilize feed better rather than relying on antibiotics to do this. And also considering alternatives. Probiotics is quite a promising field, as well as phytogenic feed additives. And if we consider the reducing the risk of disease transmission and the need for therapy, antibiotics being used as therapy, here in the context of primary animal health care, which is what we focus on in our undergraduate training at the faculty, improved biosecurity, which I believe the health sciences refers to as infection and prevention and control practices. So similarly, those practices in the veterinary sector. Vaccination of animals for vaccine-preventable diseases rather than relying on antibiotics to treat those diseases, but preventing them through vaccination. And then you've heard that happy animals are healthy animals, less likely to contract diseases. So focus on improving their welfare, and that includes aspects of nutrition and health to improve or to prevent disease occurrence in populations. And one of the other things we employ South Africa is, particularly in South Africa, genetic selection for resilient animals. Also when we consider vector-borne diseases like transmission of diseases by ticks, we can genetically select for more resilient animals. And of course, health screening for workers, because we've seen that people can also transmit diseases and resistant bacteria to animals as well, and particularly in the livestock production sector. So in order for us to implement primary animal health care to prevent diseases and the use of antimicrobials in animals, we need access to not just veterinary health services, but also human health services where we're considering health screening for our workers in the fields. The second strategy would be preventing zoonotic and environmental transmission of AMR. So here we're also looking at improved biosecurity practices, so in terms of waste management, in terms of PPE use so that people can protect themselves where they are in contact with animals, but also during food production. So this shows quite an elaborate process here, but it's not always the case. Sometimes it's quite a shorter production length, especially in the small-scale production sector, where it might just be a producer and the final product. But it's still important that good manufacturing practices and hygiene management systems are implemented in these systems and throughout the chain. So from the producer all the way to the consumer that's finally preparing and consuming the end product. So how do we achieve this preventive healthcare for AMR control? There are three pillars here that need to be focused on, and this comes from the Global Action Plan for AMR control. So the development and enforcement of robust legislation, but also keeping in mind social justice implications. Targeted extension and community strategies along the entire food chain are once again not just for the veterinary sector, but also the human health sector, because this is where our community health workers come into play. And integrated AMR surveillance systems, which I will talk a little bit more on. So in terms of the legislation, we need to address not just the control of antimicrobials, and that is in terms of access and consumption, but also biosecurity and IPC practices. And this really needs to cut across private and public health sectors to bring some sort of equality in how we're using antimicrobials across these sectors. In terms of targeted extension and communication strategies, I've mentioned the farm-to-fork approach, so education and training here from the producer all the way to the consumer, and this will include all aspects of society. And for this to happen, we really need to address access to primary animal health care and primary human health care for these targeted and extension communication strategies to be rolled out. Finally, integrated AMR surveillance. So we're not just talking about resistant organisms in humans, but in animals as well, and in the environment as well, including soil, water, plant crops, and to incorporate not just the resistance, but also the consumption of antimicrobials across those sectors and the residues, antibiotic residues that are present in those sectors. And this type of integrated AMR surveillance will really be useful to produce data for research where we can produce prediction models that can be used for risk assessments and assist for the implementation and monitoring of planned interventions. So from the Global Action Plan for AMR, before we can really have these issues that can be addressed, these are some of the things, these are the key objectives that the action plan outlines, and this is kind of the research that we focus on from the Faculty of Veterinary Sciences. So improving awareness and understanding. So here we're talking about veterinary and farmer antimicrobial stewardship so that everyone is responsible for how they're using antimicrobials. How do we address food security concerns? In South Africa particularly, producers are reluctant. They're concerned that the economics of not using antimicrobials would not suit them very well. So here we're tossing up food production versus treating highly resistant infections in people. And then food safety for consumers. So consumers also need to be made aware so that these issues affect them, even though they're not in contact with animals, but they are consuming those products and they are handling and preparing those products in their homes. Strengthening knowledge through surveillance and research. So at the faculty, we're doing a lot of multidisciplinary One Health AMR research. And I've specifically mentioned social sciences here because they are largely ignored, but we've now come to acknowledge their importance, particularly in human behavior and how people are choosing to use antimicrobials, either for themselves or their animals. Governance and capacity building, so we have quite a number of legislative concerns, and we do work with government on their platforms to address this through research and addressing social inequality, so access to not just veterinary services, but also human health care services to support good governance and capacity building. And finally, the implementation of international standards. So urgently, the WHO has called for a prohibition on the use of colistin, fluoroquinolones, and third and fourth cephalosporins for growth promotion in animals. So how do we get that into our legislation that in a way that is still socially just? And I would like to leave you with this quote from the World Bank. If we really stop and think about the role of agriculture in society and what we're hoping to achieve, we will realize that agriculture has, and particularly AMR control, has a really critical role to play in our achievement of the Sustainable Development Goals. Thank you very much.
Thank you, Dr. Govender. I must assure you that we have already started to address one of your action points here by improving my awareness. I'm now aware of the food safety after hearing the previous presentations and what the antibiotics, the increased use and over-reliance on it, and what it can potentially do, not only to animals, but to us as well. Thank you for your presentation. I would like to welcome the Deputy Leader of the TEX Undergraduate Research Forum, which is TURF, Penelope. Here at the university, particularly in our faculty, we have TURF. Now, usually when students, that's her, she's the Deputy Leader of TURF, Penelope, thank you. Now, usually students get exposed to research in their postgraduate studies, at least when I was studying. You start doing the research modules in honors and so on. But TEX Undergraduate Research Forum is meant to expose students to research while they are still doing undergraduate, so that they can have interest in research and even start with some research activities. And I know Prof. Mashamba Thompson, in the annual research day of the faculty, dedicates a particular slot to undergraduate students to present about 5 minutes or so on the research that they've undertaken. There's also an undergraduate journal that has been established for students to publish their research. So there's a drive to expose students from early on in research methodology and research activities, which I think is important. Thank you. We'll now move over to the next theme, which is research on communicable and non-communicable diseases. And we'll welcome our partner presenter from Spain, Dr. Ana Maria Iglesias Magueda.
Hi, good morning. So before, I would like to thank Dr. Daramola to host me before anything here, because he was very kind during this week was really busy for us. We had a lot of meetings and lectures, and we found common interest in research, and I'm sure this is the start line for this is a start for common research projects in the future. So I'm sure, and I also want to thank you. I'm sure that the big advances in global health are reached by multidisciplinary teams, and that's why symposium like this one is so important. So thank you for organizing this symposium. It's so important to reach big advances. So let me introduce myself. I'm not a doctor, I'm not a veterinarian, I'm more a computer scientist, and how computer scientists connect to global health. So let me introduce. I'm working at University Carlos III of Madrid in Spain, and let me talk about the accessibility barriers in medical technology. So yeah, now we know that we have technology all around in healthcare for diagnosis technology. We can find also surgical technology or therapeutic technology like that, or radio machines or MRIs, or laboratory technology, or technology also for surgical operations. And we can also find technology for patient assistance at home or in the hospital or clinics that is helping the user to measure for instance, the blood pressure. Like I don't know if I can sign with, yeah, this one. Yeah, there it is. So here we can see a person, a woman, with a blood pressure machine. And this is also technology that we usually use every day, and it is very frequently to be used. And we can also find, we also have other kind of technology like rehabilitation technology. And I know that Dr. Fernandez is going to talk about this robot in here, who is a rehabilitation robot where we have been collaborating before. So let her talk about this later. So let me focus now on the problems that we usually find in medical technology and why not everybody is able to interact with it. So let's first think, who is interacting with this technology? Of course, the healthcare professionals are the ones who are interacting with the technology, with that surgical technology to operate the patients. But also we can find that some patients need to interact with the technology that we are designing or we are constructing. So this is one example in here where this is a rehabilitation machine where we are using virtual reality with glasses, and also there is a screen, and it is like a game. So now it's time to think if everybody, a blind person, a person with hearing disabilities, or a person with mobility disabilities, or maybe a person with cognitive disabilities, all of us, or maybe an elderly people, is all the people also able to interact with this kind of machines? Because, well, we're going to see later that according to the regulation all around the world, we need to protect the rights of the person. So everyone should be able to interact with rehabilitation machines, right? So this time, using the virtual reality glasses, we need, like a blind person, maybe could have problems to interact with this machine. So maybe it's not easy for them to do this kind of rehabilitation. And we need to think in other machines for them. Or maybe this time, in this example here, we have a video conference with a doctor who is in his office or in the hospital, and the patient is at home. So with digital technology, that patient is measuring the blood pressure with an easy machine. It is supposed to be an easy machine, but maybe that machine is not accessible for her, because sometimes these kind of machines are not accessible for people who cannot hear very well, so with hearing disabilities. And we know that elderly people, just because of the age, we are all having little by little more and more disabilities or impairments, right? So it's so important to create this kind of technology accessible for all. And also to use a computer. It is not so easy for some persons. So we need to think on all of them. Here we have another example. This time we have a healthcare professional using technology to do an operation. And here they are using a big screen where they are zooming what it is happening inside the patient. And we have another screen on the back of the room, and maybe different, because the healthcare professional also could experiment different kind of disabilities. Why not? We cannot discriminate what kind of persons should use this kind of machines. So that's the point. Or here we have a very complex application also with visual images, and persons who are blind or with visual disabilities or maybe with cognitive disabilities will also have problems using this kind of applications. So the point is, are we all able to interact with the medical technology under the same conditions? Because we should do that. So that is what I'm working with. So here I included the image of a robot, because now the robotics is all around, and there are in hospitals and resident homes and clinics. So I'm sure that people with different disabilities, and in this hospital we have a lot of people with a lot of disabilities and a great variety of abilities and capabilities. We all have problems using the same machines or same technology. So we are talking about the big concepts of accessibility, but also universal design of the interfaces and design for all, or inclusive design. And this is the research area where I am working with, the human-machine interactions. So, well, I've been talking about this, so I'm going to skip it. So here I wanted to go one by one in every use case, talking about the problems that blind people, people with hearing disabilities, or speaking disabilities, or with mobility disabilities or cognitive disabilities had when they are interacting with this kind of technology. But let's skip this because I already introduced the problems. And let's go directly to the main problem. The main problem is that most of the technology that we are using in our hospitals or clinics and everywhere at home, they are not accessible nor inclusive for everyone. And what the goal of my work is to create universal interfaces for all, because this benefits to all. That means not only for people with permanent disabilities, as we already was talking about, but also with temporal disabilities. I am sure that all of us had in our lives some problems temporarily. For instance, we broke our arm or we broke our leg, and we suddenly experimented mobility disabilities. And I am a very good professional in my work, and just because of that, I couldn't do it properly. But it is not fair that just because the machine is not properly designed, I cannot do my work at that moment, right? So that's what I'm trying to fight. Okay. So we can imagine a robot like this in a waiting room in a hospital, and this robot could be, for instance, informing the patients and maybe coordinating how they are or accompanying them to the room that they need to where the doctor is waiting. So when I said that it benefits to everyone, is because it's not only because of the disabilities or when we are getting older, we also experiment all these kind of disabilities, but also because of the context of use. Sometimes if we are using a machine, a technology in a very noisy environment, I don't know if here the waiting rooms in the hospital are noisy or not, but maybe if we are on the street or we are using anything, we are experimenting something similar to that what people with hearing disabilities are used to experiment, right? Or when we are foreign people, I'm sure that a lot of people here can understand this. It's easier for us when we find the information with closed captioning or subtitles when people is talking or in a video, right? So this is something similar to that people with cognitive disabilities or learning disabilities usually experiment. Or maybe if we go to the dentist, that day is difficult for us to speak properly, right? So there's another temporal disability there. And when we are using a mobile phone, for instance, in a very sunny place, it's difficult to read everything that is on the screen. So that's what people with visual disabilities usually experiment also. Of course, when we broke our leg, it's similar to a mobility disability. So we know that according to the World Health Organization, there are 50% of the population experiment different kind of disabilities. And here in South Africa, we have more than 3 million people with disabilities. So that's something that we need to think on. And according to the regulation, here in South Africa, we know that the Constitution of the Republic of South Africa is protecting the rights and dignity of the people with disabilities, and also the Human Rights Commission is protecting this. But focusing on accessible technology, that it is why I'm here, all around the world, in Europe, Africa, and globally, we can find different regulations that mandates products and services, including technology, should be accessible for everyone. That means also for people with different disabilities. And that's why, according this regulation, there is a big need of design the new technologies to be accessible and inclusive for all. And that means that if we are the ones that are in charge of buying the new technology or designing the new technology, or depending on what we're doing, what I wanted to ask you is to be careful with all these things, because it's necessary to be accessible for all, and now it is very difficult to find that accessible technology in our clinics in Europe, also in all around the world, and also here. So what I usually do in my work is to, I do both. I collaborate in the design of new technology and also do evaluation of the current technology that we are using to improve it and make it accessible for all. So I need to think in everything, not only in the interaction component with the healthcare professionals and the patients. That means not only the hardware components, if we need a screen or if we need maybe a special keyboard or something like that, but also the applications, the software that we need to use, for instance, and automatic speech recognition to be able to chat with the technology instead of using a touch screen or other things that could be not accessible for everyone. I also, I'm in charge of designing the behavior of this technology. What's the behavior? So sometimes we need to use artificial intelligence algorithms to adapt to the user needs. And for instance, if we think in a robot that is a mobile robot that is moving around, for instance, it is very important to teach the robot how to move and don't, for instance, crash with objects or other persons. And also, I'm in charge of designing a good look and feel so the people who is interacting with these machines are not scared. The machines are intuitive, usable, and all these things that are so important. So, and we usually do it in a co-design method, using co-design methodologies involving the users in the whole process of the design. That means the patients, the healthcare professionals, all of them are included, are involved in the whole process of designing the new technology, because they are the ones who really knows what they need. So they are involved on that. So just to finish my presentation here, I wanted to talk to you about 3 different success projects where I'm being collaborating. The first one is it started in 2015. It was an European project, and we were like 8 different teams in different countries in Europe collaborating. Ones were engineering, and others were artificial intelligence experts, and others were interaction experts. We also, another team was a hospital with users. So a multidisciplinary team, we all were working to get this success in this project. And you can find more details about this project in this publication that I'm presenting here. But if you want to contact me, I'm going to tell you more about this. This robot that is in the image, we designed it from scratch. So there was a team who did the look and see, the physical external components of the robot. Another team was in charge of the artificial intelligence. So it was really, really interesting to work all together. And what this robot were able to do is to assess the balance, also the independence of the patients, and also the cognitive capabilities of the users, because there was a geriatric assessment. So this robot was helping the doctors getting objective and subjective data, doing this directly these assessments with the patients, with the elderly people. So another success of project, it was integrated in 2022 in a resident home. We were working from some years before, but it was completely integrated in a retirement home in Spain also. What we did this time is to use the previous robot that we designed for the other project and implemented other kind of tasks in it. This time we call this robot, we're doing different tasks as announces. He was announcing the agenda in the retirement home this night or this evening. We want to have a concert, a piano concert in room number 3. This robot was also providing information about the weather. Today is a sunny day. Let's play together in the patio, or these kind of things. And it was really, really good. Always also socializing with the patient, not the patient, but the elderly people in the retirement homes, the residents. And we were also really happy with these results. And finally, here I also had another publication about this project. And finally, we want to present you here. This is not the only thing that I have been working in, but I am working in much more other. But just to summarize, and directly related to global health, I want to present these 3 ones. Fernando Fernandez is going to present you later this last project. It is a rehabilitation robot who is helping with artificial intelligence and gamification. It is helping a lot of people to do that rehabilitation exercises in a very fun, way. And so let's Fernando tell you later more about this. But I've been collaborating in all of them, trying to do this interaction more accessible for all. So that was my role. So just to finish, thank you very much for your attention. There are a lot of things to do yet all around the world, and I'm very open for new collaboration. So let's fight against the discrimination. There's discrimination also for people with different abilities and capabilities, and let's create all together, use accessible technology for all. So that's my talk.
Thank you, Dr. Ana Maria Iglesias. You raised a very pertinent question actually there, because often we come up with these technologies and think, wow, this is fantastic. This robot can talk to you. But do we think about those who cannot hear when we celebrate it? Because we often celebrate the technology that we have, whether it's visual, reality or anything, but we seldom think about people who might not have the capacity to use that particular technology. So I think it's a challenge out there to the people who produce this technology or think about it, that when they come up with these big innovations, they also think about the different disabilities that we have. I mean, you highlighted that we have about 3 million people who have disabilities in the country. That's about, what, 5% if we are close to 60 million or something like that. That's a lot of people. And they need access as well. And permanent disabilities, temporary disabilities. So I actually never really thought about that. And I'm sure many people thought about technologies and innovations, but many may not have thought about the accessibility in terms of the kinds of people who have the capacity to use those kind of things. Thanks very much for muchas gracias. We are moving on to a rep from the University of Pretoria, from the Faculty of Engineering and the Built Environment. So we welcome Professor Alawande Daramola.
Thank you very much. I appreciate the privilege to be part of this symposium. This morning I'll be speaking on predictive analytics for decision-making in healthcare. I will start by giving a profile of what we have been doing and try to also connect that with my interaction with Prof. Anna in the last 4 days. And just like the program director said, a lot of times we think about innovation. We think about, we have new ideas, we want to profile new technologies and solutions, but we don't think inclusively, and we don't think in terms of accessibility. So my interaction with her in these few days has actually opened me up to that perspective, and going forward, that really influence some of the things that we'll be doing going forward. By way of my research interests, I do research in knowledge-based systems, machine learning, software engineering, and also informatics. And the informatics aspect actually focuses on how technology affects people. You know, how people interact with technology, what are the barriers to acceptance, adoption, and all that. But specifically in terms of the things I will look at AI in healthcare, explainable AI, AI for healthcare, example AI for healthcare, and also human-centric explanations. Now, the landscape of AI has evolved over the years, and we started with what we call logic-based systems, or what we call symbolic reasoning systems, and then the concept of machine learning came in, where we explore patterns in data to be able to actually predict or make intelligent decisions. And then we have the advent of artificial neural networks, which actually models the way the human brain works to be able to solve problems. Because not all problems can be solved through symbolic reasoning. That is, it's not every problem that can be abstracted in form of what we call if-then rules, antecedents and consequences. For example, recognition, pattern recognition. If I see two people and I'm able to infer that maybe they are related, maybe a mother and a daughter, that is not based on reasoning. It's based on pattern recognition. That is, I'm able to associate the pattern between these two entities together, and on the basis of that, I'm actually able to draw an inference. And then, of course, deep learning and then generative AI, which is like the in thing now. And for a lot of people, the only form of AI that they can really relate to it are the GPTs. But the good thing is that AI systems has a lot of application in healthcare. And there are so many use cases of this, from diagnostic imaging to treatment personalization, virtual health assistance, robotics in surgery, and also predictive analytics for patient outcomes. So all these are possibilities. And going forward, AI indeed has a lot to offer healthcare. However, the challenge is that we have a lot of potent artificial intelligence algorithms, but they are not explainable. That is to say that it's one thing to generate results It's another thing to be able to explain the rationale or the basis for the generation of that result. And that is actually what ultimately will lead to usability of these results. So what you find, for example, you have an AI system suggesting to a doctor to do something or to an healthcare professional. There are some other questions that one will want to ask. For example, how did you come about this? To what extent can I trust this result? What if the scenario is different? What would the result be? These are all things that, these are rational bases to actually query a result before it becomes acceptable. And this is an area where a lot of AI systems, for now, are still deficient or lacking. However, there are a lot of efforts along these lines. Now, the most potent AI algorithms, typically the ones that are based on what we call the artificial neural network architectures, deep learning systems, are also what we call opaque systems, in the sense that they could actually bring very good results, but cannot explain how those results came to be. And so that becomes a problem in terms of the acceptability of such results. So currently what we have is that you have you have a system, you have training data, you're actually able to train a system. The system is able to, based on the pattern in the data, actually generate results for the user. But the user is asking, why did you do that? Why not something else? Why do you succeed? When do you fail? When can I trust you? How do I correct an error? These are all questions that a system should be, a user needs to get answers to be able to actually accept or believe that result. And so, what explainable AI strives to do is to ensure that all these questions can actually be answered. That is, after you have the result, you're also able to understand how and why that particular result has been generated. We believe that, to a large extent, if systems are able to do this, then the degree of acceptability or uptake of AI as a technology in healthcare will actually be more. So we can say, for example, that healthcare is one of the domains that we call explanation critical domains. That is to say that it's not just enough to have a result that is accurate or seems accurate, we must be able to actually explain it. Now, in this area, working with my students and my group, we've had a number of contributions, and I'll just talk about a few of them. Now, but the general concept, really, in terms of applying predictive analytics with respect to, in the domain of healthcare, is actually to follow the typical machine learning life cycle in terms of actually exploring the pattern that is in the data, train your data set, using some algorithms, and applying the right treatment to ensure that the result is accurate. And then when we get the result, then we can do, for example, what we call post hoc explanation. That is, how can we actually try to explain what has happened in a language that is meaningful to the intended user of that result. Now, so following this perspective or following this approach, we've actually done some work based on a grant we got from the South African Medical Research Council, for example. Based on COVID-19, we were able to actually identify the critical factors of mortality for persons that were infected with COVID-19. We use a data of 490 COVID-19 patients that were admitted into Tygerberg Hospital in Cape Town. And we used 3 models for this particular work. That's deep multilayer perceptron, support vector machine, and also extreme gradient boosting. Now, based on this work that we did, for example, we were able to identify, based on this cohort of patients that we actually looked at their data, we were able to identify the 6 most critical variables of COVID, of mortality, okay? And that has to do with length of stay in the hospital, the amount of time they spent in the ICU unit, that is those that actually required emergency care. Also, the number of days in total that they spent in the hospital, and then the blood clotting factor, and also the blood pH. So based on the data that we have, and we also identify some variables that were critical in terms of the severity of, the condition of these people. For example, the age of the patient. We also looked at the PF ratio, the troponin T, and the ferritin. These are things extracted from the blood of this particular patient. So based on this, we're actually able to identify these critical factors, which could actually inform, going forward, how a medical practitioner could deal or undo these kind of situations. In another study that we did, looking at people that have been vaccinated, there were cases where persons were vaccinated, but at the end of the day, they still died. Post-vaccination. So we also looked at factors that could actually affect, that could lead to what we call reinfection. Somebody has been vaccinated for COVID, but also got infected again. Yeah, we also looked at that, and our results showed that, for example, the body temperature, the total cholesterol, the glucose level, the blood pressure, weight circumference, body weight, body mass index, hemoglobin level, and physical activity per week are things that actually, could determine whether somebody can be reinfected after COVID-19 vaccination or not. Now, all these things I've shared, for example, are things we got by exploring data. But the good thing also is that these results actually were confirmed by clinical studies. Okay? We're actually able to compare the results, from our AI algorithm with those generated from clinical studies. And these were actually found to be valid. So that is to say, really, that AI actually has a lot to offer in terms of predicting patient outcomes. Another one that we did recently, for example, now this using an open data set, that is a what we call the post-vaccination incident, adverse post-vaccination event reported, event reported. This is actually an open data set called VAS, where persons have actually post-vaccination, people that develop complications and all of that. And here we were actually interested in persons that have cardiovascular disease risk factors, particularly those that had comorbidity condition in terms of hypertension, people that had, high cholesterol, people that also had issues with high blood pressure. Okay, so all of these we actually looked at, and we actually wanted to see how, when this category of people had problem post-vaccination, what is the probability of them surviving or recovering? Dying or recovering. And based on this, so what we did was, this is just showing the process workflow that we follow in terms of, extracting data from that particular open data set, training and all of that, and then, of course, also applying the explainability model to actually understand exactly what was going on. In terms of performance, we also identified the best algorithm, and then we applied the explainability model on the algorithm that had the best performance. So what we found is that, for example, increased mortality risk for this category of people, for those that are older, the risk is higher. That is when they have post-vaccination adverse event. And then, of course, the number of time that they spend in the hospital, those that had precondition of diabetes, high cholesterol, and high blood pressure, okay, the probability of them dying due to that post-vaccination adverse event is higher compared to those that do not have that. And then, of course, for decreased mortality risks, you have those that do not have any comorbidity condition, okay? Also, those that do not have any form of disability, those that didn't require emergency care when they had that vaccination advance event, and also those that also complete their vaccination, the doses. There are also people in the data set that people that, for example, somebody has taken, let's say, Pfizer vaccine, and then instead of taking 2 shots, took only 1. Okay, so people like that have a higher risk than those that actually completed the vaccination dosage. So all of these things is not to show that indeed it's actually possible for us using AI to actually explore patterns in data and come with very meaningful conclusions that are valid even in the clinical setting. Now we've gone a step further, for example, to create a decision support tool like a web app where, for example, a doctor, for example, could provide some parameters, give input, and then on the basis of that, actually obtain prediction, and then also explanation in terms of why somebody got reinfected with COVID or not. Now, these are just a list of some of the papers we published on the work that we have done in the aspect of explainable AI. Now, but the key thing here is that it's not just about providing explanation. Who is this explanation for? That is the key question. And so we need to think about what we call human-centric explanation. For example, the explanation required by a doctor in terms of the depth of detail could be different from the one that you want to give to a nurse, or you actually even want to give to a patient in terms of the level of detail and all of that. And so for explanations to be human-centric, it should offer learning. That is to say, by reading the explanation, somebody should have a better understanding of what is going on. It should also be relevant. There should be justification for that particular explanation, conceptualization, and also it should be context-oriented. So it's very important. And that is where the aspect of, for example, accessibility comes in, okay? Maybe by virtue of the level of my education and expertise, if I look at a graph, I can know exactly what the graph is saying. But another person needs to read text to be able to actually understand that explanation. So context is actually very important. And then, of course, the issue of accessibility also comes in. For example, if somebody is visually impaired, for example, how do you deliver that explanation? So maybe you need a voice-based service that can actually read that out. So thinking of different types of people and how this explanation can actually be presented to them. And so, currently now, with my group and my students, we are talking about the concept of explainable decision support systems, okay? And the things that, so the capabilities of this kind of system is that first, you have systems that can actually offer explanations that are relevant, adequate, and trustworthy. Also, this explanation is also designed in such a way that there is the understanding of the stakeholder, the recipient of that particular explanation, in terms of understanding of the attributes of the stakeholder, in terms of usability. How do you present that explanation in a way that it will be usable? And then also accessibility. All of this informed by understanding the recipient of that particular explanation. So that is to say that you cannot have one explanation that is fit for all. With respect to the nature of the stakeholder, the explanation has to be customized and contextualized to make it relevant to the receiver of that particular explanation. And then, of course, you should offer insight, and also there must be a way to evaluate this explanation in terms of the quality. Are we sure that this explanation is actually fit for the scenario, for the current scenario? So we must also be able to actually evaluate that. So those are aspects that we are looking at. In terms of, just to close, in terms of our ongoing work, so we are looking at how we can apply this concept of explainability, in healthcare, AI, example AI, for example, to studying chronic disease, metabolic syndrome, cancer diagnosis, also organ-focused inquiries. Now, this is something that we found not to be common. I mean, for example, can we look at diseases that affect the liver? Okay? Or maybe you want to look at diseases that affect a particular specific organs of the body. What can we actually know about all these different diseases and actually study the pattern and the nature of, infection and severity and all of that that happens to, for example, the liver, the heart, and all of that. And to be able to do this, there are a lot of possibilities. And two of these we're actually trying to explore currently. For example, we can build what we call knowledge graphs, okay, that are focused on specific scenarios. Now, a knowledge graph is an organized representation of real-world entities and their relationships. Okay, so the real-world entities, for example, could be an event, it could be a situation, it could be a concept, it could be an object. So it's actually possible for us, for example, to extract knowledge from the literature. Assuming, for example, we are interested in studying tuberculosis in Southern Africa, we can actually accumulate all the knowledge we can find about that, papers that have been published, things that have been said, and all of that, and extract this knowledge and create this knowledge infrastructure. But in doing that, we also do it in a collaborative way. That is to say, we also bring the medical scientists, for example, into the picture so that they can validate some of these conceptualizations or some of these relationships. Once you have that, that becomes a knowledge infrastructure that AI algorithms can use as a basis to explain their results. We can also try that, using the same concept, we can also build what we call large language models, GPTs, that are domain-specific. So the advantage of that, so when you have this integration of knowledge graph and LLMs, it means that we can actually have GPTs that are also explainable. So it's not just about the fact that you ask your GPT a question. The GPT can also explain to you how it came about that particular answer and all of that. So these are things that we are looking at, and it's something that's really exciting, and then we see where that will lead us. But in doing all of this, accessibility is key. That is to say that even when we provide this technology, we want to think about everybody. We want to think about the different categories and different classes of people that are in the society. Yeah, so, but to do all of these things, there are a number of challenges that we still need to, some of the things that we need to actually think about. The level of AI readiness needs to be higher. There are still people that have an aversion for AI, okay, because they are just, maybe they don't know what to expect and all of that, or they are not used to it, or it's not part of their training. We also need more resources. And one of the vital resources that we need is actually data. Even though data is available, mostly it's not in the form that we can use it directly for AI. So that's also something that is very important. And then, of course, everybody needs to learn, you know. I mean, new trainings. We need to shed some things, some old, you know, fears and all of that, and embrace the new possibilities that AI offers. Thank you very much. I stop here.
Thank you, Professor Daramola. Contextualizing explanations, I think that's also very important. A couple of weeks ago, we had a presentation from this professor of family medicine from UKZN, and he was talking about the patient that, you know, came to his consulting rooms, and I think he had diabetes. So the patient wanted to know, what is this thing? What does it do to your body? Then he tried to explain, you know, how it works on the body and everything, until he mentioned something about the feet. And the patient immediately said, ujeke. And the doctor thought, oh, well, maybe that's the explanation for diabetes in their language. But then when he asked what that means, it turned out to be that means, you know, people who don't like you pour something on the floor, and if you step on it, it goes through your feet and affects you. And the message was lost in translation. So he had to, you know, call back the patient and explain that, no, it is not the people. It is diabetes, and, you know, you just need to treat it this way. So I'm excited that, you know, Professor Daramola talks about the technology that can be relevant to different people. And I mean, that also talks to the different cultures and the understanding of disease as well. Because sometimes you think that your explanation, however beautiful and scientific and clear that you think it is, might mean something completely different to another person, and eventually maybe even cause harm to the community, because that gentleman might have thought that the neighbor was onto something, and that is why he was suffering from what he was suffering from. Interesting. Thank you very much. We are moving on to the fourth theme, which is about strengthening public health system. I must mention, before we have our two speakers, after our second speaker, Dr. Sean Patrick, we will take a group picture. So I'm appealing to everyone, don't rush out. We need your picture and your smile. So we are going to take a picture outside. There are banners. Our photographer is already positioned to take that group picture. So be prepared for it. And you can practice that smile already. We are moving on to the first speaker from our partner universities in Spain on the theme on strengthening public health system, Dr. Fernando Fernandez Ribello.
Okay, so thank you very much for the opportunity to be here today. Thank you, Dr. Paratzaki, for hosting me during these days. It was amazing to get into the surgery theater in a surprise way and see a real surgery. For a computer scientist, you can imagine that it was kind of a shock. Well, so my goal today is that you and after my talk, you understand two main concepts. The first is what is socially assistive robotics, and how can we use socially assistive robotics in rehabilitation. But before, just very quick, I come, as you know, from University Carlos III of Madrid, and I work in the PhD group in which we basically do artificial intelligence with one focus, decision making. Okay, so any decision, any system which has to make decisions, autonomy is kind of our focus on research based on classical artificial intelligence and also in machine learning techniques. So what are assistive robotics? So basically you can understand assistive robotics like robots that help and support human users, okay? So you can see here some examples of rehabilitation robots, mobility support, grippers of arms, do you know surgery robotics? So there are a lot of different robotics platforms that are created with the goal of supporting or helping the humans to solve a specific task. What are interactive social robotics? Well, the idea of these systems are robots which main task is any form of interaction with humans. Okay, so basically what they make is to have this social interaction, and to have this social interaction they have to have some human characteristics, like they have to show emotions or to react to emotions. They have to have some personality or to adapt to the personality of the users. And they have to make gestures, to have a nice looking, and these kind of things. For a huge amount of different applications like home robots, entertainment, promotions, maybe you have seen some waiter, a robotic waiter, and systems like that. So if we mix both things, assistive robotics and social interactive robotics, then we find this new area that Matamacharik described like socially assistive robotics, which are robots that try to assist people and to solve problems for people in a social way. So, for instance, a classical way to differentiate these social assistance robotics for other methods is that typically social assistant robotics is a non-contact assistive technology. So typically we don't touch users, and maybe we don't touch patients. Okay, which is also relevant because it increases safety issues, and then the deployment of this system is easier than with other contact approaches. Okay. Well, why social assistive robotics is important for this for today? Because here you can see the evolution of the publications that contains the term social assistive robotics in medicine literature. Okay, so you see how is the growth of the use of these new technologies in health system because of many different applications. Okay, and in fact, one of our focus in our research for more than 10 years has been to improve rehabilitation services. Why? Because as you see here, the prevalence of people with at least one condition who will benefit from a rehabilitation service in Europe is very large, but also it is very large in Africa. Okay, so you have here many people who is requiring rehabilitation services, and the problem here is that more than 2/3 of all these individuals who need rehabilitation, they don't have access to these services. Okay. And sometimes when services are available, they are inadequate. There is a lack of rehabilitation professionals and insufficient coverage. So that is telling us that we need to improve the systems. And the one way to improve systems is bridging gaps with rehabilitation and assistive technologies, and to analyze how assistive technologies can improve rehabilitation systems. Okay. So one of the main ideas is that the assistive technologies can enhance personal independence and societal participation in rehabilitation system, and that is a paramount issue. Well, basically, the point here is that socially assistive robotics can be a great ally to improve adherence in neurorehabilitation treatments and also in active aging. We will focus today in neurorehabilitation, but we will see that we can use social assistive robotics, obviously not to substitute the clinician persons and occupational therapists and so on, but to provide with an additional technology or co-therapist that can support them in the daily practice. Well, with this idea, we're working in the university for several years in social assistive robotics and its application to rehabilitation. From that, we created a spin-off, which is called Inrobics, a spin-off from Universidad Carlos III Madrid, dedicated to digital health overall to rehabilitation. So we are now more than around 12 people. We are located in the scientific park, also in the University Carlos III of Madrid. And what we have done in all these years is, firstly, is to understand a basic things. We were computer engineers. We were people experts in artificial intelligence, but we didn't have any idea about rehabilitation or clinician things, okay? So one of the main things for us was to work together with people in Hospital Nacional de Parapléjicos de Toledo, Fundación San José, Virgen del Rocío in Seville. So we collaborated with many different clinical settings for doing this research. So what did we create? Well, basically, we were thinking in create social assistive robots to help in rehabilitation. You will have later on a clear idea of how we do that. But I would like also to give just a very small flavor of what we need from the technological point of view to create social assistive robots. So the first thing is that we will have a system that is able to interact socially with people. Okay? So for doing that, we need AI. We need artificial intelligence, and we need like a brain in the robot. So we need this software brain embedded in the robot that is able to control the interaction of the robot with the patients. Because one of the interesting things of humans is that we are very unpredictable. Okay, so we need a robot that is able to socially collaborate with unpredictable people. Okay. So we have all this robotic system with all this AI, and we need to be able to store a lot of information from this interaction. Okay, so that's why we use the cloud. In our case, we use Amazon Web Services, in which we store safely and with all the and ensuring all the regulations in data protection and things like that, we can store all the data. And then we have what we call the accessories. Why do we call accessories, for instance, to the robots? Because we are able to use any robotic platform. Okay, we can use the Now robot, we can use Piper, and we could use many other robots in different ways. Okay. We have also, it is very important for clinicians, measuring devices. So we are able to measure things from outside. We can see the people, we can measure the heart rate of the people, we have accelerometers, we have inertial sensors, so we can get a lot of information from outside. And then what is the main important thing? Is that we need to provide the clinicians with an easy way to use our system. So that's why we designed a lot of different apps in which we can maintain the information about the patients, we can monitor the patients, we can monitor the sessions, the rehabilitation sessions, or we can even see the reports and the evolution of the treatments after they are realized. Okay. So for oops, sorry, it's not. Okay. So what did we do? So basically, we have like 3 different systems. So we have what we call in robotics RAW, which is a social robot for physical and cognitive stimulation. We have also this robotic system, but instead of a hardware system, a real robot, we have developed it virtually. So we can use maybe in a tablet or in a smartphone, which has the advantage that it doesn't require the deployment of a real robot with the classical cost associated to this deployment. And then we have all the analytics system in which we can analyze and evaluate all the robots. So as you see, the first system is composed of the robot, the apps, the sensors that we use, the heart rate sensors, so we can evaluate the elements of the system. We have the virtual system that we can use both at home and in also the clinical setting. And we have all the apps where we can see the information. But I think this is a very visual project, so that's why I always introduce a video which you will see really how it works.
InRobotics is the first clinical game-based solution that combines social robotics and artificial intelligence to provide physical, cognitive, and psychosocial stimulation, promoting the mental and emotional well-being of the patient. The goal is to establish a connection between the robot and the patient through a highly personalized experience coordinated with healthcare professionals. This helps the patient stay active, manage stress, relax during their regular exercise sessions, and feel supported in their recovery process. Our methodology integrates guided exercises such as mindfulness, breathing activities, and guided visualization to enhance physical and mental well-being. InRobotics offers physical training, cognitive exercises, wellness activities, yoga, and dance sessions.
We had no idea whether the adherence to the treatment, if the children would relate well enough to the platform to maintain focus during the sessions and complete those treatment sessions. Indeed, adherence was excellent. All of them completed the sessions.
Everything that happens during the session is recorded in our assessment and results system through sensors and cameras integrated into the platform. Healthcare professionals can track their patients' progress.
So far, the experience we've had with the children has been very positive. In fact, some children have genuinely felt that Now interacted with them. Talk to them, and even responded, to the extent of giving a small gift to the robot. It has been a very positive experience.
In the face of a shortage of innovative care resources and an aging population, Inrobix provides a solution that addresses these needs and contributes to building a more inclusive future.
So two main things that you need to take into account here is that first, this is not future. Having robots is a reality. So we have that in these robotic platforms in more than 10 hospitals in Europe. So you can already take them and use them. And the second thing is, remember that this is not a toy. Okay, this is a clinical device, and it is certified as a clinical device in the European Union. Okay, so it's important that you understand that this is a tool for helping the clinicians in the rehabilitation sector. And of course, that for obtaining this certification is we had to pass all the scientific analysis. So here you have 4 examples of published papers in which we analyze the usability of the systems from the user experience, but also we analyze the effects that they have from the clinical point of view, the positive effects that they have in the rehabilitation process of the patients. So I think that's all. I want to be fast because we are in break time. So thank you very much for your attention.
Thank you, Dr. Rebelo. I already see a lot of hospitals in the future using those social robotics because, I mean, they are interactive, and for children, they are stimulating them. They relate easily to them as well. I mean, it's like they play around and less intimidating, I can imagine as well. And I think some of the doctors, physiotherapists, and all those people can actually use them to assist them in rehabilitating the patient. Thank you. Looks like technology is going to solve a lot of our problems. We need our engineers and our healthcare professionals. Thank you. We have our last presentation, which is also the last presentation under this theme of strengthening public health system from our own Dr. Sean Patrick from the School of Health Systems and Public Health in the Faculty of Health Sciences.
Thank you very much, everyone. Thank you for the opportunity to speak about some of the work that we are doing. And while I was thinking about this, I thought, how do we frame this? And I had to look at the 4 different pillars that we have. And so just to disclaim, I only arrived back in the country yesterday, so I didn't have a chance to actually speak to the group. But while I was sitting there and I was looking at, or I was actually listening to all the presentations, I actually realized that the work we are doing and what I will talk now about, what are these right competencies for tomorrow's health workforce? We actually touched on each one of these in the different presentations that we had. So what I'll talk about very briefly, just introduction, I'll talk about the public health workforces from the public health side, and looking what are some of these skills in this future healthcare workforce. And I'll show you some examples, and I'm glad the previous speakers talked about we actually need to bring about change, and the curriculum is one way of doing that. And very often we don't think about that the curriculum needs to change and actually try and align with some of these newer technologies that we're using. And then I will end at the end thinking how we can strengthen the public health workforce and actually touch on some of the other work that we have spoken about today. So we do know that as far as the systems are concerned, there are different system building blocks. And what they ideally do, all of them together, is we want to increase either the quality of the healthcare, as well as in making sure that everyone can actually use all of the healthcare. But I'll just touch on one part, which is the health workforce. And a lot of the colleagues in the school actually do deal with some of these other issues. But I'll focus specifically on the health workforce. And why that's important is that we really need to ensure that we have access to service, number one, but access to good quality service, but also it aligns to the new technologies that we are going to use. So yes, the landscape is evolving and we need these new skills. And a lot of the speakers before really talked about the majority of these things, whether it's advancements technology and healthcare, as we heard now with as far as robotics are concerned. We know the disease patterns are starting to change and we actually need to use some of the technology. But some of the skills that we need our next generation to have is really to understand the new systems that we are using. They need to be able to be adaptable and need to collaborate within the different disciplines. Okay, so how do we go about doing this? So we do know that within the evolving landscape, for example, there are different rapid advancements to technology, shifting disease patterns, etc. And really where we will focus most of the presentation on will be how do we build and train this next generation workforce. So to bring this into context, we do know that there was actually a paper published last year that talks about 3 different zones really where we can do most of the work. And this is really around defining what these services are, looking at competency-based education, which I will talk a lot about, and how do we measure these. So the approach is really divided into three different parts, and really that is how we can ensure that this next generation workforce actually does have all of these skills. So how that is done, and some of the work that we are doing, is around curriculum development, interprofessional education, simulation-based learning, continuing education, mentorship, and feedback, for example. So I'll talk a bit about curriculum development. As far as interprofessional education is concerned, listening to the speakers this morning around One Health. The conference I was at last week, we actually presented an interprofessional education module we have at the University of Pretoria, which is around One Health, that actually combines 1 week where we have medical students and veterinary students in one class. We talk about concepts around One Health, talking about how these two groups approach problems from different points of view, and really try and share and say, but we actually need both of these disciplines in one room, thinking of pandemic prevention and preparedness, for example. You can't really split these two. So it's one of the ways that we're actually trying in doing that. So what we did, and I'm glad that that we talked about artificial, as far as artificial intelligence is concerned. We actually asked students in the postgraduate diploma class, what do they think, or what are their perceptions about artificial intelligence, and what do they view, because they are now starting in their postgraduate students right now. But if they then do go into the workforce, what are some of their thoughts? And what they found is, and what we found when what they said is that they perceived it to be very useful. However, they felt that they weren't quite sure what their jobs would look like in a couple of years' time. They are busy training right now, and they, with everything that's starting to change, robotics coming in, they were just a little bit weary. But what they had mentioned is they wish that in their training programs and not just in their final year, that they actually do get to understand what AI really is, what the applications of AI could really be, that they actually can understand that. Because now it's terms thrown around, and they aren't quite sure. And one of their recommendations was that they need either further studies, and actually can we incorporate some of these issues in the curriculum. They can actually learn more about these. That's exactly what we did. We have a master's module right now. This is the second year that's being offered, data science and public health. And with computer science actually also came on board. So in the first week, so I split it into different sections. So the first week we cover the basics around data. Data management tools, and we go around software tools, what we can and can't use, what are some of the statistical and analytical skills that you would need, and there we show how the programs work. If you can clean your data and you have this large volumes of data, where do you even start before you even start seeing the picture? Then we move on into week 2, where we actually teach how do you visualize these large data sets. We do the data visualization, we do a bit of coding as well. It's very, I must just preface this, this is public health students, don't necessarily have a background in computer science, so we really start off at the very basics that at least they can understand. In week 2, we now talk about what is the application and relevance to public health. I think the robotics, for example, is a great example, where students can actually see this is technology being used, how it can be used as far as public health is concerned. And we do have a number of speakers that come in that actually have used some of these tools, and they come in and they would share some of the examples. I think that is sort of one way of collaboration, where in a class like this, where it's quite a large class, where they can actually see some of these practical examples. And then, of course, the last thing we also touch on is some of the research responsibilities, because we do know that that's, we haven't really talked about that quite a lot, as far as access data is concerned, as far as privacy is concerned, and some of the ethical considerations are concerned. So it's quite important, and we also realize that in order to reach a large number of students in training this next generation workforce, our residential programs are really not sufficient to reach this large group, so there are some online programs as well. And we have the postgraduate diploma in public health online, and these numbers have actually probably doubled by now. We do have our Master Public Health in Contact, and we're actually moving that to an online environment. And One Health is one of the components we're including in that program, as well as artificial intelligence and data science and public health. So just a bit about the postgraduate program. We actually launched in May 2020, which was convenient. Well, not convenient, but the pandemic started in that point. So it gave us a great opportunity to actually see how an online program in public health could work. And it's been quite, it worked quite well. In order to ensure that the competencies of our Master's Public Health students are standardized, in Schools of Public Health in South Africa, we are, all of us are coordinators of the programs. And we are currently working on trying to standardize that at all universities in South Africa at least, that every single graduate out of the Master's Public Health program has the same or at least similar competencies. And one way of doing that is to share the work we're doing, and data science is just one thing we're going to do, actually try and standardize that across the university, so that any graduate leaving any program would at least have some of these basic skills. But we realized that not only the students, but also the academics themselves also might need to have to be able to upskill themselves. So I belong to the Global Network of Academic Public Health, and particularly on the Faculty Development Working Group. And we have a meeting in a couple of weeks' time where we actually talk about these issues, where it's all well and good trying to teach all of these newer things, but academics often are specialists in one subject. And now we're moving into artificial intelligence, moving on, and we actually don't really give support to the academics who want to move into this environment. So the idea when we have our meeting in 2 weeks' time is to talk about all of this, and we have representatives from all of the continents, and we're all coming together, and we're trying to see how academics can also be supported. We're talking about all of these issues, the next generation, but how do we go about doing this? Let's just collaborate on that. So in the morning we talked about how the health system can be strengthened, and this is one example during the pandemic where we made the commentary. We said that within this short period of time, such great advances were made as far as technology, as far as access to information, for example. But yet we have the issues like malaria elimination that's been on the agenda for such a long period of time, but yet resources and funds are being moved around from one place to the next. So surely we should build on all of these. And one issue that came up quite a lot is how do these systems work? What is the governance around these? And strengthen the health system in particular. I think there are lots of lessons that we can learn, and there have been lots of changes that have been made in these past 2 years. And we should actually use that. And what we had argued here is that if we train a workforce on the one side, but we also have accessibility of the services we had, and also we strengthen the community, engage the community more in developing some of the interventions, pilot testing the interventions, and they can actually then retain within the community that can continue. That would actually ensure that we can prevent any future pandemics, or at least be resistant to them. So there are some. So in the last couple of slides, I thought, if we're thinking about collaboration and learning between what the two countries have achieved and where some of the limitations are, it's really about these integrated approaches where we can learn from one another. Training the workforce. There are obviously programs in your own institutions that work really quite well tailored to your specific healthcare system. But I think there are ways in which there can be learning from one another. As far as innovative health strategies are concerned, I think the robotics is a great example of that. We have some of our own as well. Looking at community engagement, human resources development, sharing of knowledge is quite important, and one of the reasons for why we are here. And then lastly, when I thought, how do we put this all together to really to summarize and take everything together? And what we're looking at really is how do we sort of future-proof the public health workforce? And it's really about the skills, the training approaches, some of the evaluation and enhancements, future strategies, but it's really this collaborative effort and partnership, and the whole purpose of why we are here, to really bring everything together in order to ensure we can strengthen the health system. So in conclusion, I think if we can train a workforce that is able to adapt, that is able to use technology, is not afraid of words like artificial intelligence, for example, that we, as soon as students start, whether it's in their first year, to actually start talking about what the applications could potentially be. If everyone can see what their role really is, it makes it much easier, it makes it much more receptive. The essential competencies we really need is that to master these digital tools and platforms, that we're able to analyze these large volumes of health data. Electronic health records, for example. I know in Spain you have electronic health records. We are one of our provinces, we're piloting it. So there are many things that between the two we can learn. Interdisciplinary collaboration, also be able to adapt. Again, enhanced training models, integrative skills, and health needs. And then I think what's also important is also for the workforce to understand what the progression matrix really could be. And from the students' perspective, that was really quite clear. They wanted to understand, if I now embrace the technology, will I lose my job in 5 years' time? Should I even pursue this career in the first place? I think it's just to try and understand that, yes, there will always be a role, and where does your role fit in? And then to benchmark and implement, which what we're trying to do, that we have this standardized way of actually teaching these collaborative efforts and the Global Health Network. So when I thought about this, I thought, okay, what are some just 4 things that I thought we can sort of learn and work from? And I just use these examples, but I think there is an opportunity, and I think throughout what I've listened to this morning, there are quite a number of issues that we can collaborate on, learn from one another. And I think also one of the things we should not exclude is that within the training programs that we have, there's an opportunity to come in in and share an example and say, this is what I've done as far as robotics is concerned. It's applicable to public health, it's applicable to physiotherapy, for example, so that when a student is actually thinking about their research project in the first place, they're not afraid to actually look at some of these. And we often expect a master's student or PhD student at that point to now want to embrace all of these things. We're actually from a much, as soon as they start, we should actually be doing that. So thank you very much for allowing me to share a bit of the work that we are doing. Thank you.
Yes, it's not the end yet, but you must hold on to it.
Thank you. Thank you very much. I didn't expect that. Thank you, Dr. Sean Patrick, for your presentation, that the workforce must be educated and taught to adapt to technology. I was in this gathering some time back. I won't say which type of gathering, and the leader was busy warning people, beware of this technology. It's going to take your jobs. And this was an influential person in the community, warning people against the dangers of technology, that if you are not careful, it's going to take over your lives, your jobs, everything, your thinking. So, well, I didn't know what was the point of that, but yes, it was, we need a lot more education to make people aware that it is there to help us and not to replace us necessarily. I must confess that I am a fan of Spanish soccer. And one of my goals is to be at the Santiago Bernabeu in Madrid or Nou Camp in Barcelona. And I see that one of the big goals of this project, you know, Alianza Cuatro Universidades and University of Pretoria, is to cross-cultural exchange. And I know soccer is part of the Spanish culture. And even here in South Africa, soccer sits at the root of our culture. And I think maybe we should have a conversation about my dream. But all in all, I'm excited that we have this partnership, and this is only the start. And we have a lot from the presentation. There's a lot that can come out of this. These collaborations hold a lot of solutions to our global problems, actually. In the health sector, but it shows that it needs collaborations from all these different professionals, all the different faculties, from the engineers, from the social sciences, from the humanities, from the vet sciences and the health sciences and all. So we need to all work in a concerted way to solve these problems. The presentations made that very clear. So can we just give a big round of applause to all our presenters, please? Thank you very much. We are going to have a big photo shoot just outside. Fantastic.
Please. We want to thank you very much for presenting this event. We want to thank also our researchers coming from Spain, of course, but also all researchers and the University of Pretoria in general for this wonderful event, and especially you. Thank you very much.
Thank you very much. Thank you. Okay, the photo will be done later, but I will give my colleague an opportunity to explain a bit of logistics afterwards, because the program doesn't end here. We still have some exhibitions, we still have some tours, but then, you know, Ronald has got all the specifics, so he will give us all the details of what is going to happen. Ronald, please.
Hi, good morning, everybody. I'm Ronald. We would like to showcase our faculty. There's a lot to see, but unfortunately we had to select a few places for you guys to just get a glimpse of what we have to offer at the faculty. So after this, everybody will go for the comfort break, and that will be between now and 12 o'clock. At 12 o'clock, our Spanish delegation and anybody else who's interested in seeing NUMERI, which is the Nuclear Medicine Research Infrastructure, and the state-of-the-art Faculty of Health Sciences Library, can meet, let's say, at the wall banner, the curved wall banner at 12 o'clock, and we'll take the group then to NUMERI and then the library afterwards. Then everybody else who stays, we've got our research entities who have exhibition tables. You would have seen those as you walked in. Those stations will be there between 12 o'clock and 1 o'clock, or between now, the comfort break, and 1 o'clock. Then we will have lunch here, just outside where you've had your refreshments for now. Then at 2 o'clock, we will come back into the venue. Okay, thank you very much.
Javier ¿qué?
Gómez Oliver.
Gómez
Oliver.
Olive. Pues si hablas con Clotet, mi sobrina es su segunda.
Good afternoon, colleagues. Welcome to today's panel discussion titled Priorities for Academic and Scientific Collaboration between Spain and South Africa. So this is really part of our broad discussion that we had under the theme Global Health at the Crossroad. And I want to acknowledge Maria Herrero and Professor Claire Newton for putting together this panel discussion for me. All I had to do is just do pretty face and come sit here with the dignitaries. Thank you very much, Claire and Maria. So it is an honor to have you all here today. And this really promises to be an engaging and insightful dialogue on a critical intersections of global health, research, and collaboration. So our countries, Spain and South Africa, although the global distance, we share the common goals. We share common goals in driving innovation and addressing health disparities. So both our nations bring unique strengths. So from South Africa, we have expertise in One Health, as you saw. We also have expertise in public health, and also we have shown you some expertise in innovation through the tours that you had. And we know also Spain is also bringing a huge amount of expertise in similar areas, and also leadership in health technology and clinical research. So together, there is a vast potential to create synergies that will benefit not only our two countries, but also the global health landscape at large. So today's panel brings together thought leaders and experts from diverse fields. As you saw in our presentations, the presentations came from diverse fields. So today we have Mr. Dan du Toit. He started his career in South African government, in a department that was then called the Department of Foreign Affairs, where he trained as a diplomat. Since 2002, long time ago, he has been attached to the Department of Science and Technology, which is now called Department of Science and Technology and Innovation, and where he has notably served as a department's representative in Europe, and he was based in Brussels. And in 2014, he was appointed as the Deputy Director General responsible for the portfolio of international cooperation and resources. So over the years, he contributed to multiple initiatives in supporting a diverse and rich international portfolio of partnership here in South Africa. And he represented South Africa in diverse multilateral forums, including the OECD, BRICS, and the United Nations, and also various structures related to African, regional, and continental cooperation. In February 2021, the Square Kilometre Array Observatory, the Global Radio Telescope Project, elected him as the vice chair of their council. And I also have with us Dr. Santiago Herrero, whom I will introduce also. He is a Spanish career diplomat. He has served as a culture consult in New York, programming director at AC/E. I don't know what the abbreviation stands for. He also served as cultural special advisor for Secretary of State for Latin America and the Caribbean. Cultural counselor in Tokyo. He was also in charge of the cultural consular affairs in Islamabad and Oslo. He's currently a Spanish Director of Cultural and Scientific Relations at the Spanish Agency for International Cooperation and Development at the Spanish Ministry of Foreign Affairs. Welcome. We move on now to another one of our panelists. We have Dr. Helena Ramalhinu, who is recovering from a cold right now. So Helena is a full professor in economics and business in the economics and business department at the University of Pompeu Fabra in Barcelona, Spain. She has a BA and master's degree in statistics and operations research from the University of Lisbon in Portugal, and a PhD in operations research from Cornell University in New York, USA. She has begun involvement in different research projects and consulting for business firms in the area of operations research and logistics. Helena has published many articles in prestigious international journals and also in logistics. Helena also has presented her work in international congresses and conferences. She teaches various undergraduate and master's and PhD programs in her university. Her research interests include operations research, scheduling, combinatorial optimization, and meta-houses. I cannot pronounce that word. Itinerary local search. I don't know what this area is, but it's quite an interesting area that I'm going to Google after this. And heuristic, what is this?
What?
The heuristic.
Oh, don't worry, I will explain
Search optimization as well. Vehicle routing and applications. This part I understand. Supply chain management, logistics, operations management, and healthcare. That I understand. Our next panelist is Associate Professor and Professor Gomez Olive. And Professor Gomez Olive has a PhD in medical epidemiology and a specialist in preventative medicine and public health. Professor Gomez Olive is an associate director and head of research at the MRC WITS Rural Public Health and a Health Transition Research Unit at the School of Public Health at WITS University. And he has 25 years experience in rural Africa. He worked in Rwanda, Mozambique, since 2005. Well, he worked in Rwanda and Mozambique since 2005 and in South Africa. And his research main interest is intersection of HIV and NCDs along the life course, focusing on the health and well-being of older populations and the strengthening of integration of chronic disease management and primary healthcare systems. So last but not least, we have our local researcher, Professor Erica Labey. Professor Erica is a biological anthropologist in the Department of Anatomy at the University of Pretoria here, and a director of the Forensic Anthropology Research Center. She teaches the courses in human osteology, human evolution, forensic anthropology, and mentors several master's and PhD students. Her research focuses on bone trauma and the biological profile. She regularly consults for forensic anthropology cases for South African police services. Over the past 6 years, Professor Labey has successfully coordinated 2 Erasmus Plus capacity building projects, making the first time for University of Pretoria to serve as a project coordinator for these grants. Her team develops Africa's first, they're the first to develop Africa's first digital repository for human skeletal remains and 3D printing, they 3D printed the continent's first complete human skeleton for educational use. So thank you very much. Welcome to our panelists. And we will start the panel discussion now with just, questions that we also need to answer within the next 40 minutes, because we have eaten a lot into our hour, which we were given an hour from 2 to 3. So I will start with Mr. Dutoit. I know which side my bread is buttered, so I start at home. So, Mr. Dutoit, how can South African government support and facilitate stronger scientific collaboration between these two countries, Spain and South Africa, really particularly addressing global health matters?
Okay. Thank you very much, and thank you for the opportunity to participate in this conversation. I suppose before I answer your question, the question we should ask in the government, actually, do we want to do that?
Okay.
Do we want to invest in strengthening collaboration between South Africa and Spain? Now, I think fortunately for all of us gathered here and organizers, that answer is unequivocally yes. Of course we would want to do that. And that is first of all because it's one of the cornerstones of science policy in South African government. And for the Spanish colleagues in the room, I work for the government, so I'm from the Ministry of Science, Technology and Innovation. And one of our cornerstones of our policies are that science knows no borders, because we know that's how science progresses. Science advances if we work together, if we share experience, if we share expertise, if we share resources. And for South African science to progress, because even though we like to think, and we do, punch above our weight, we're a relatively small science system compared to bigger science nations. So we need to be connected. So international partnerships are absolutely crucial. It's part of the lifeblood of South African science. But then secondly also, Spain is a friendly country. Spain is an economic partner, it's a political partner, it's a social partner of South Africa. So there are many reasons why we would want to invest in the South African-Spanish relationship. And after some years where there's been a bit of a lull, we are absolutely delighted, thanks to the colleagues, Maria and the team who put this together, and the support we are receiving from the ambassador. So yes, we would want to do this. But then what can we do to advance this collaboration? First of all, I mean, like science, collaboration really depends on people. It starts with people. And exactly what we are doing here today, investing in relationships, developing networks, that's so crucial. Yes, we live in a globalized world. It's very easy to connect digitally. But investing in people-to-people contact is our first priority. So that's why, for example, we have a whole range of instruments to support scientific mobility, supporting short-term visits for South Africans to go abroad, student mobility. We have launched at the end of last year a major new program, what we call, our president launched it, which we call the Presidential PhD Initiative, which is to have a greater, irrespective of the quality universities we have in South Africa, like the University of Pretoria, we also know that South African science will benefit by a significant cohort of South African students studying abroad. So we want to increase that. And certainly Spain is one of the countries we will be targeting to send South African students abroad. So investing in people through our National Research Foundation, there's various funding instruments to do what we are doing here today. But then secondly, also to create instruments and opportunities for research and innovation partnerships. Of course, we know science needs funding. It doesn't happen on its own. Now, currently, and this is a topic which we will continue with our counterparts in the Spanish government, we right now do not have any active bilateral instruments. Program Director, you joked, yes, 2002 is a long time. I can remember a time when we actually did have a South Africa-Spanish bilateral program, which There's no reason we cannot revive if we converge on that. But we do not even have to wait for that. And specifically in this field of global health, South Africa is a very active participant in the funding programs of the European Union. And of course, which Spain as an EU member participates fully. So there are ample opportunities, and I think all the Spanish colleagues will know, and many of the South Africans know, South Africa participates in the Horizon Europe Framework Program, where there's a whole portfolio of South Africa, European Union health collaborative projects. And before coming here, I asked the team to check, and there are actually 10 projects there already which involve South African-Spanish collaboration. So we could have a very specific focus to use those instruments, including the program which is known as the Africa-Europe Global Health or European Developing Countries Clinical Trials Partnership, which offers multiple funding opportunities for South African and Spanish partners to work together. So that we'll do. But then just lastly, and that's why it's so important for us, and we're grateful that the ambassadors here, would want to really see that scientific collaboration and academic collaboration becomes an integral part of the overall political and economic partnership between South Africa and Spain, and privileged to be with the colleague from the Spanish Foreign Ministry, because that's how we strengthen the relationships. So that would be my introductory statement. Yes, an unequivocal yes. We're very interested to support this collaboration, and we can do this by investing in people-to-people contact, and then also for active research and innovation partnerships.
Great. I'm happy that your answer is yes to that question, because you are in good company here at University of Pretoria. Our answer is also yes. We want to collaborate with Spain, and with your help, we can make it happen. So I have a question now for Mr. Herrero. And Mr. Herrero, how does the Spanish Agency for International Cooperation and Development envision the future collaborations between our two countries, particularly in the context of global health? Well, first of all, thank you for having me here. Thank you, Ambassador. It's always a pleasure because now in my position, I'm traveling a lot, and whenever you arrive to a country in which there is a great ambassador, very professional, it's so nice, and you make me feel proud of being a Spaniard. Just imagine if I say, no, we don't want to collaborate, no? So it was very good that you say yes. So let me put me in a place. I work in the Spanish Development Agency, that is under the umbrella of the Foreign Affairs Ministry, and my position is Director for Culture and Science. So what we do is we try to promote Spanish culture abroad and also science. But we go one step forward. I mean, it's not just to come to a country and to show what we do. It's try to put together and to have links between the sector, the cultural sector, or the scientific sector in that country and the one from Spain. And as you said before, it's about people. It's about the person that they are going to work together. And what we are doing now in our DNA, of course, is Latin America. It was like our first focus. But now we have changed, and we have now a strategy, 3-4 years, to work in Africa. Why? Because Latin America, we have like a lot of cultural relations. We have the language, we have heritage, but we understood that Africa is it's a land in which we can communicate and we can create groups of people that are going to work together. So that's why, that's the first thing that I wanted to underline, that now we are focused on Africa, and that's a good news. That's why when you say yes, I say like, we also say yes, of course. Yeah. And also because I think that we share like common values in health, talking about health. No? We conceive health as a human right and a key element of sustainable and peaceful development. If you have health, if you have a good system, you can collaborate between these two countries, even in the area. It will give you the opportunity to have development. And that's one of the key points that we need to take into account. As you said before, I think that we need to, we don't have a direct flight, of course. That will be fantastic. But anyway, Ambassador, you need to work on that. That direct flight will be the good thing. We need to take Spaniards, Spaniards and people from here, and they need to interchange things. Also, we are working on the other side on trying to have Spanish as a science language. I know that it's quite difficult, so I know that all over the world, if you write an essay in English, everybody's going to read that. So for the time being, we are going to carry on in English. But yes, of course, I think that after this this table, it will be very nice to try to work together and try to have some projects, common projects, that bring Spaniards here and bring South African into Spain and try to link, not just because, not just in a way in talking about computers, no. I mean, to have a presence, to have presential, to take, to touch each other, I think is one of the key elements to work and to have like a project for 3-4 years. Thank you very much. We're very much happy to take you on that and develop projects that are beneficial to both countries and focused on global health areas that we highlighted during the presentations earlier this morning. So my next question now is to Dr. Helena Ramalhino. The question for you, Doctor, is relating to your current position. So what specific initiatives do you think can strengthen the academic collaborations between our two countries to help us address the global health challenges?
Okay, thank you so much. If you don't understand what I do, I must say the same with medicine and life science. My only relation with medicine, life science is through my son who's studying medicine. So when he comes home and explains me things I cannot understand too. Say, please, can you say it in simple words? So right now here I represent an alliance of 4 universities. The University Autónoma of Barcelona, University Carlos III of Madrid, University Autónoma of Madrid, and University Pompeu Fabra from Barcelona. So we are 4 universities that, yes, we compete for students, for professors, but we also collaborate, special international relationships. And we have been trying to collaborate in internationalization, which is quite important for the universities now, and it was always important, but I think now it's more important, because to solve the global problems, you need a global set of researchers. It's not only, and also multidisciplinary. So we represent these 4 universities that are quite young. 2 of them were created in '68, another one in '89, another in '90. So we are very young universities, very international. We have international professors, we have international students, and we like to go international. So we create this alliance, and in our case, we are the internationalization vice rectors, you call it DVCs, and we try to promote mobility between some countries in Asia and Africa that we don't reach individually. So we don't have so much bilateral connections. So the 4 of us, it promotes more these equity relationships. So we come here to South Africa to visit our partners. Of course, our partners is University of Pretoria, and I'd like to congratulate the people who organized this, which is a fantastic event. We have WITS in Johannesburg, we have Stellenbosch, we have UCT, Cape Town University, and also Western Cape University. So these are our partners here, and Free State, sorry, I forgot Free State. So we are our partners, and we promote mobility. And as my colleague said, sometimes it's good to see the people, to see the faces of the people. Then we can go on Zooms. But if there is like a first connection with the people, it's easy then to develop like a project. So we promote these mobilities for PhD students, for young researchers and also senior researchers, and also administrative staff, which is quite interesting too. And so the students can stay about 5 months, and the administrative staff and all the research and teaching staff can be 5 days plus 2 in both directions. So we would like this to be an equilibrium, this equity relationship in both directions. So we've been doing this for some time. since 2016, if I'm not wrong, and we've been done more than 500 mobilities in Africa and Asia. In South Africa, 134. So, and we would like to promote this. We get the funds from Erasmus Plus Mobility, and this, I think this is the beginning of a relationship, that you go visit your partner in Africa or in Europe, and then you have to go on and go for an horizon, go for other projects to really create this relationship. And we did have some successful cases. So yes, we'd love to have a relationship between South Africa and Spain, and this is my first time here. So only this year I've been twice. So you see, we are very fun to come here.
Okay. Thank you. I really admire you for your strength as well, because I just said your current position. I didn't explain to you guys. So Helena is a president for the 4 Universities Union. And she has a cold right now, but she's strong enough to carry the 4 universities and also come here and present. I also wanted to highlight, Helena, that with the mobility projects in South Africa, a lot of our researchers here are also football, fanatics. So we must incorporate football teams, things.
We don't discuss this in the team because we'll be enter a fight.
Thank you. So I know your exposure to health is just through your son, so maybe we'll talk about football instead. The next question now is for Dr. Gomez Olive, yes. So the question is really with regards to the research collaboration. So how can the research collaborations between these 2 countries address the intersection of infectious disease and HIV, as well as non-communicable diseases, such as the cardiovascular diseases? I know this is your research area of expertise. Yeah, thank you very much for having me here. Every time that I go to a roundtable or conference, I think I should change my surname to Gomez Zulu. It will be very easy for everybody. You made my life easy. Then, the collaboration, South Africa has a huge network of universities and a lot of experts on HIV and non-communicable diseases, the same as the 4 universities of Alliance for Universities, with a lot of experts on these 2 issues. And I would like to mention that part of the universities where Alliance for Universities are working here in South Africa are part of another network. It's a network funded by the Department of Science and Innovation called South African Population Research Infrastructure Network. And in this network, we have 6 research units in 5 provinces in South Africa. We have the University of Witwatersrand, the University of Johannesburg, the Department of Family Medicine here at UP, and also Stellenbosch University, Cape Town University, and University of KwaZulu-Natal, that each of them are part of one of these infrastructures. And with them, we are following around 700,000 people here in South Africa. And we are visiting them annually 3 times and collecting socio-demographic and health information of this population. Then this is giving us a huge platform to follow the dual epidemic of HIV and NCD. Long ago, I think it was 10 years ago, in a study, international study, South Africa was at the highest level of hypertension in population over 50, with around 70% of the population being hypertensive in that study. In our studies in the SAPRI network, we see that still 2/3 of the older population are hypertensive. And when we are talking about HIV, we know South Africa has around 8 million HIV positive people, which is represents around 13% of the whole population, around 16% when we are talking about 15 and 49. But then we stop. And people normally don't study what happens after 49 years of age. And we know that after 49 years of age, still 23% of the population, at least in rural South Africa, rural Mpumalanga, where I work, are HIV positive.
And this brings a situation where we have an aging population, we have a lot of older people with HIV and a lot of older people with non-communicable diseases, together with many other non-communicable diseases, mental health problems, dementia, diabetes, etc. And then this is a huge area of research that we think that together and with new collaborations with Spain, we can develop. We have seen this morning how the new innovative systems, AI, machine learning, robotics, any of these other innovations that have been presented this morning, they can also be implemented into these rural areas and also in the urban areas where sapling is established. And I think that this could bring a new partnerships that will help us to treat, control, and create awareness of these multimorbidity conditions in South Africa.
Okay. Thank you very much. I think it's important also really to contextualize the the disease focus areas in both countries. So obviously our disease burden in South Africa is still very much, the HIV is still one of the issues, the problems, and one of the leading diseases here that is causing a lot of problems. And now we also have TB, which is very much associated with HIV as well. So it will also be interesting to also know from the Spanish side what's the disease burden on that side, and what can we learn from each other in addressing these disease burdens. So thank you very much, Professor. So now we move on to our UP researcher, Professor Labey, whose research already caught our visitors' eyes when they walked in and they saw the work that she was doing. And then I know there's already been questions. Maybe some of the questions I'm going to ask you've already answered, but this is now for the entire team to hear more about your work. Also, Professor Labey is one of the top researchers, one of the researchers who attracted the highest amount of funding from the Erasmus Plus. And so, Professor Labey, how has your experience been as Erasmus funding beneficiaries? And how has this helped facilitate the cross-disciplinary collaborations between our two countries, especially in the context of your field, forensic anthropology? Okay, as far as forensic anthropology is concerned, our two capacity building grants. The first was to build a digital repository of skeletal remains for the purposes of research, for international and national research, to better address our missing and unidentified persons globally. While we have a huge situation in South Africa with missing and unidentified people, it is a global phenomenon. Whether you are in Europe and trying to get from Syria to Italy or other countries, we are missing people, and that is a social and mental health conundrum. So we started with building the repository as a way to build capacity in Africa to encourage international research and to better address how can we look at the identification of an unknown person and how can we repatriate them back to their families. For our second Erasmus grant, we focused both on education, medical education, and education in forensic anthropology. And while there is a lot of governmental services, whether the International Commission of the Red Cross or the UN, who are available to create governmental infrastructures for dealing with the dead, for physically dealing with the dead, what we really need is training people on the ground to deal with human remains and to analyze them, and to make sure that analysis is appropriate to the culture in which the people are working in, and that that person gets returned to the correct family member. In order to do that, we need to address and reach more people. So in my career, I have taught in Colombia and Brazil, in Finland and in the Netherlands, bone trauma. It's how to interpret what happened to a person after they died and when there's no longer soft tissue remaining, and how to come up with a presumptive reason for their death. And what we want to take all of this capacity that we've built into the next Erasmus grant is say, how can we reach this training online so we can reach more practitioners in Africa,
who need to do the same jobs that we do in South Africa, but there's just not the manpower, there's not the resources, and unfortunately they don't have the access to the training. When we can go virtually and digitally, we can create that access. And we can create online learning avenues by which they can learn, okay, this is how I'm going to analyze these skeletal remains. This is how we're going to treat them. This is how we're going to maintain our chain of custody between receiving them and returning them back to the enforcement of law. So that is where we are focusing, and it is a global situation. It is not only Africa, it is Europe, it is North America, it is particularly Latin America as well, to where we need to collectively think with engineers, anthropologists, not only biological anthropologists, but cultural anthropologists, and computer scientists to bring together and advance our technologies for improving not only our maintenance of the deceased, but our treatment of them and the returning of them to their families.
Thank you very much. So often when we think of health and we think more about the living and not what then happens, after. So well done for addressing this, for really championing this field in the University of Pretoria. So colleagues, we don't have much time left. We only have 5 minutes now to wrap up. So I would like to hear from each of our panelists, what takeaway message would you like to share with our Spanish researchers and University of Pretoria researchers on how we can effectively take forward this collaboration, starting with Dr. Helena.
Well, thank you so much. I mean, what I can say in 30 seconds is that we're going to open a call. So everyone is invited to apply to have this interchange collaboration between the University of Pretoria and the 4 Spanish universities. A good thing is that when you come to Spain, you can visit 4 universities, not only one, which is kind of interesting because we are different like any other university. So, and I think the panel, I talked with the people and everyone was very happy. They have very good discussions, and that's exactly what we want, to initiate this collaboration, coming here, our researchers presented, your researchers presented, and let's see what's coming out of this, but I believe it will be very positive for both countries.
Thank you, thank you. And then Professor Mngomezulu.
Well, for me, I think that what we have to work out is more areas of synergism between South Africa and these 4 universities in Spain, because there are, I've seen this morning, a lot of areas where we can work together. We have a lot of things to do improving health systems, especially in rural areas. We have to work a lot on how to evaluate new policies that are being implemented, like the salt that was implemented, or reduction of sugar, how these are actually impacting in the non-communicable diseases, and other interventions on introducing and making people aware of the conditions of non-communicable diseases, HIV and all. Then creating areas of synergism between South Africa and Spain, I think that will be one of the targets to do.
Thank you. Mr. Dutoit?
Thank you. From a policy perspective, what I find really encouraging is that, good collaboration is like a good relationship. You cannot force it. You cannot artificially force it, artificially force someone to like you.
No.
But all the ingredients are here in terms of scientific complementarity, of value addition through collaboration, and then a shared perspective, a policy perspective of why we need to work together, specifically in the aspect of global health. And that's very encouraging. But then, as also with any good relationship, you shouldn't take it for granted. You need to continue to invest in it, and you continue to nurture it and care for it.
Yeah.
And that's certainly something we look forward to be doing with our Spanish counterparts.
Thank you. Thank you. We'll do it the African way. Okay. So we move on now to Mr. Herrero.
Yes, as you said, no, it's like a garden. You need to garden, You need to water it, no?
Yeah.
From our point of view, I think really that Spain is trying to support the health system from a global and a local point of view. But I think that you really need to, what we can do from the agency is two paths. First of all, technical, and the other one, financial. I mean, you need to have money to do this. We have increased in the last 3 years our budget for science. For do this, so this is really a success. I mean, to be here now is a success. So congratulations to the university. But what we can do is try to create that framework, and of course try to put more money to do this kind of events. If not, it will be impossible. So maybe, as you said, we need to take care every day, but we need to put money on it. If not, it doesn't happen.
Okay, thank you. Professor Labe, how can we help you to take your work forward in collaboration with the Spanish researchers?
For everyone who I spoke to today and who I haven't spoken to, we're looking for one more European partner on our next Erasmus Capacity Building Grant, which is looking at building 3D competencies in South Africa. We have partners with Tanzania and Finland. We just need one more European partner if they're interested in online education in areas of bioprinting, 3D imaging, 3D printing, with personalized aspects in forensic anthropology and osteology, as well as human evolution, and using our digital technologies to advance education in Africa.
So thank you very much, colleagues. We would have liked to have time for questions and answers, but we only have 3 minutes, which is the 3 minutes for really for the panelists to take pictures. So thank you very much to my panelists. You've been very great. We enjoyed, having a conversation with you, and thank you to the audience. You've been a great audience. And yes. I would like to introduce the Dean, Professor Diaja, to come forward and introduce our Her Excellency, the Ambassador for Spain to South Africa. Is that how? Yeah. Spanish Ambassador to South Africa.
Thank you, Professor Bashaba Thompson. Esteemed colleagues, distinguished guests, partners in academia, my take-home message was yes, yes. See. Yeah. So I just want to echo that from my side as well. It's my honor now to introduce His Excellency Ambassador Raimundo Ribeiro Rabio to you to do some closing remarks. His Excellency holds a master's degree in economics from the University de Oviedo and a bachelor's degree in law from UNED. He's also completed specialized studies in European affairs, foreign trade and leadership program in public management and global leadership. His diplomatic career, which began in 2001, includes key positions such as the trade advisor in Nigeria and diplomatic roles in Tokyo, Pretoria, Dakar, and Chile. Quite a journey, it seems to me. He has served as Director General for Africa and since 2022 is Ambassador of Spain to South Africa, Lesotho, Comoros, Madagascar, and Mauritius. Proficient in Spanish, English, French, and I hear a bit of Afrikaans as well, and other languages. He has received several national honors for his service. Please, let's welcome our ambassador from Spain.
Thank you very much. Baie dankie, Dean. was bijbeendrukkende. Feels a little bit like being at your own funeral when they read your CV. And that is niet waar, by the way, but most of it is a lie. First of all, thank you very much, everybody, for convening this meeting. I think it's a fantastic opportunity. Thank you to my Director General for Culture, where I don't see now, Santiago, for coming all the way to South Africa. May I say, on the way from the airport, he already gave me fantastic news, which is that we are planning to open a cultural and scientific center in Pretoria at the Spanish Embassy, which I hope will keep pushing these partnerships that we've been discussing today. Yesterday, I had a meeting with a symposium with Saya and the Instituto de Empresa. 3 weeks ago, the other two big MBA colleges in Spain, IESE, of which I am an alum, is one of the courses that the Dean mentioned, in global leadership. Not that I'm much of a global leader anyway, but at least I went there. I think it's a fantastic university. And the third one is ESADE. We're here. We have the 4 universities coming today. I think that it was very well picked. The hint was it was not too subtle. I think Professor Ramalhinho, I'm sorry, a Portuguese name, I think she picked it up. South Africa, the University of Pretoria needs a 4th partner in Europe, and one of the 4 universities hopefully will be one of them. So all that to say that Spanish universities have a keen interest in South Africa this last year or two. Things like the Square Kilometre Array telescope. We have the Spanish Association of Scientists here in South Africa. It's the only Spanish Scientists Association in the whole African continent. It's here. So all this speaks to the interest, keen interest in Africa in general and in South Africa in particular by Spanish universities. And what we're doing today, as has been said, is meeting face to face. It all starts with persons. Director Dutoit, fully agree with him. As him, I'm also a career diplomat. It's basically our job to put people in contact. We know nothing about nothing, but we know the people that know things, and our job is just to get them to talk to each other. I'll try to be brief, but let me apologize first and foremost to my cultural counselor, Elena, sitting there, who wrote fantastic words for me that I'm completely ignoring. Because I want to tell you a little story that I think is appropriate to tell in the University of Pretoria, Faculty of Sciences and Health. I was Director General, as I did mention, of Spain when, during the COVID crisis, Director General of Africa, for Africa, of Spain. And I want to apologize because the foreign policy reaction, not the health reaction you could say for a while during COVID, I think it happened all over the world, our foreign policy was taken over by medical experts. Medical experts know a lot about health, not much about foreign policy. So basically our health policy was every single European citizen will be vaccinated before a single COVID vaccine leaves the European Union to treat other citizens of other places all over the world. I don't know if that's medically correct or not. It's not my place to judge, but I know for a fact that from a foreign policy point of view, it's very wrong. And it clearly sent the wrong message to Africa. And I think this is the place and time to apologize. Then, fast forward a couple of years, after 4 years of being Director General, I bedank. I resign. Well, it's 4 years, it's over. You don't need to resign, they'll let you know. And so I go to the minister, and the minister says, well, now you'll be ambassador, where do you want to go? I say, well, South Africa, pretty obviously. I had already been here posted, as the Dean mentioned before, and yeah, I want to go to South Africa. And I say, okay, fantastic, we'll ask for your agrément. For the government of South Africa to agree to you going there, and say, fantastic. So we asked for it, and the government of South Africa replies, yeah, great, send the guy. He seems smart. And then, as I was ready to pack up all my things and catch a plane, you guys, not you, but I'm sure somebody in this room was probably involved with it, discovered the Omicron variant of COVID. And we went into lockdown again, well, just for South Africa. We shut down South Africa again, so I could not take a plane. I had to wait for about 5 months to come to South Africa. My whole family was, they had finished school and everything, waiting to come to Pretoria, and they had to wait. So, for the second time, apologies, because you were punished for doing your job and scientifically right and being faster than anybody else. I tell you all this because I think that very often in Europe, we look at science in Africa as a secondary field, as a secondary thought after maybe Europe and the US and Japan and all the big players. And I think that's a big mistake. Director Herrero made the point very well. Spain wants to look to Africa because we can learn more from who thinks different than us than from those that think just like us. Issue number one. Issue number two, you've proven, as this little story of mine tried to show, that we have a lot to learn from you. And there's a lot that we can learn from South Africa in particular and Africa in general. And that is basically all I want to say. I'm very excited to see universities coming here with this same message. I'm very excited to see, when I was Director General, I tried to not only bring students on the Erasmus program to Europe, which is the usual thing we do. By the way, Spain is the #1 country in Europe for Erasmus students. So when other Europeans think about going to study to a different European country, they come to Spain. I did my Erasmus studies in Denmark, by the way. I'm an Erasmus alum, as is, most Europeans are. So when an Italian, a German, a Lithuanian, a Polish, whatever, they choose a country to study for 1 year under the Erasmus program, #1 destination is Spain. So there might be a reason for that. Not so much when it comes to students from other countries, from African countries, Asian countries and so on. They choose maybe Germany or France or something, not so much Spain. So you're missing out. And that is only for students, but I want to, not only students from Africa to go to Spain, I would like Spanish students to come to Africa. It's a lot to learn. It's a lot to learn, #1. And #2, teachers, professors, the faculty, to do exchanges and links. Elena, the cultural counselor, is working on that. Director Herrero came to South Africa to work further on that. I am at your disposal. The embassy is at your service. Anything you need, please contact us, because we are very keen on creating those links. Thank you very much. That's all from me. Thank you.
Thank you very much, Your Excellency, His Excellencies. It's a great pleasure to have you here. And I think we've come to the end of the symposium. Before we close, I just would like to give special thanks to Prof. Maharaj in his absence, the DVC for Research and Postgraduate Education at the University of Pretoria, who met the Faculty of Earth Sciences 3/4 of the way in funding this event, and also to the Dean of the Faculty for supporting us and funding this event. Dr. Helena, for bringing all your researchers from the 4 universities. Thank you very much. And the coordinator, whom I've been interacting with for a while, thank you very much for making this happen. This was a collaborative initiative between the Spanish Embassy, the 4 universities in Spain, University of Pretoria's Faculty of Earth Sciences, and Department of Science and Innovation in our faculty, specifically the Department for Internationalization. Our colleagues are there from Internationalization. Fundi has been coordinating this from the DRI side. So thank you very much, colleagues, the organizing team, Gertrude, and everyone who has been instrumental in making this event successful. We have some gifts. So this is the African way to show that we want this relationship so badly. So my boss here, Gertrude, also makes things happen all the time, especially when it comes to gifts. I have a gift for Dr. Guinot. How do I pronounce that? Dr. Laura, that's better.
That's better.
Okay.
Thank you very much.
Thank you. So I also have a present for Dr. Martin. That's so nice. Your name is really nice. Irene Martin. So it's not a Spanish name, Irene Martin.
It gets translated into any language.
All right, thank you. Wait till I tell you my full name. You also struggle. And then we have Dr. Carolina. And our president, Dr. Helena, president of the 4 universities. Thank you very much, and thank you very much, colleagues. I believe the next session now is a group photo with the ambassador. We waited the whole day till you arrive to have, oh, thank you very much. You see, this is really working. You see, the relationship is working. So, colleagues, we were requested by our photographer to have a group photo right here, in here. Ambassador in the middle, we waited the whole day for this photo. Okay. Everyone in the photo? Or maybe... For the photo, it will look weird. Yeah. Yes.